അതിനെ ഇതിലേക്ക് കണക്ട് ചെയ്യണം, ഈ സ്ക്രീനിലേക്ക്.
Maybe.
അതോ ഈ ലാപ്പിൽ?
Can you work here? There must be some HDMI, right? OBS. Using the FU testing?
Yeah.
So video sharing is on, screen sharing is on. I'm also getting it. Hey, do you have space on your laptop? No, I'll bring one. No, yes, we came later. Train later.
Train?
Yeah, so we train today.
Isn't he supposed to be living here somewhere?
No, Kumumba.
He left
more earlier. Yeah. He came on there.
അപ്പോൾ കൊച്ചിയിലായിട്ട് ഇല്ല ഇപ്പോൾ.
No. No, Sham is there. He lives here. But hybrid, Allah. I mean, you have. Hybrid. Wow. This is a lot of people. Info team? Hey? Info team. 9 മണി. ബസ്സിലൊന്നും ഇറങ്ങി Oh shoot, I forgot. No, I forgot. Oh. ഇല്ല ഇത്രയും മാത്രമേ ഉള്ളൂ. വീഡിയോ ഇട്ട് വന്നില്ല. You haven't uploaded the video from the last meetup, right? Suhan sir, no need. Only the screenshot. So only. Screenshot വലിയ കുഴപ്പമില്ലാന്ന് തോന്നുന്നു. Okay, നമ്മൾ സ്ക്രീനിൽ കുഴപ്പമില്ലാന്ന്. We'll start 10:15. Yeah, okay. 10:15. 10:10. That's how it is, right?
Quick questions. How many people here are students? Nice. And like which year? Final year. Oh, how many first years? Interesting. Like what inspired you guys to attend FOSS Meetup? Twitter കണ്ടിട്ടാണോ തന്നെ? Where did you know about this? Huh? Which college? Oh, okay. Campus. Nice. Yeah. How about others? How many people are here from Amrita? Okay. Not that big a number. How many people are employed? Like which company? Maybe we can start from here. Huh? Zoko. Okay. Like what do you guys do? And how about you guys? Same company?
Yeah, it was fine. It was fine.
ANJ. Okay. And how about you guys? Huh? No worries. Ego. So we are trying to actually improve the participation of employed folks. കോളേജിൽ നിന്നാണ് കൂടുതൽ ആൾക്കാർ വരിക. അതൊരു പ്രശ്നമായിരുന്നു ഫോർ എ സർട്ടൻ പീരിയഡ് ഓഫ് ടൈം. കാരണം കോളേജിൽ നിന്ന് വരുന്ന ആൾക്കാർക്ക് അത്ര എക്സ്പീരിയൻസ് ഇല്ല ഫസ്റ്റ് ഓഫ് ഓൾ. അപ്പോൾ what we are thinking of building here with this community is basically something where people can give and take back, right? Like we ourselves are giving in the hope that in the future we'll also be able to take back something from in the future, right? So like when we are building a community, we need brains to come and join us so that they can also share, and then from that we'll earn something, right? So that's the whole idea behind improving the participation of employed folks, because we know that you guys are working with really interesting problems. So you guys will also be sharing new things that even students can learn from, right? കോളേജസിൽ ഇപ്പോൾ നമുക്കറിയാം അവസ്ഥ എന്താണെന്ന്. അവിടെ അത്രയൊന്നും ഇന്നോവേറ്റീവ് ആയിട്ടുള്ള തിങ്കിങ് ഒന്നും നടക്കാറില്ല ഇപ്പോൾ. In few colleges it does happen, but in most colleges, like 99% of colleges, that's not the way things work, right? So that's the gap that we are trying to fill by building community bonding networking events like this, right? So yeah, how many people have already known about the FOSS United mission? Can you raise your hands if you okay? Like how many people have been participating in FOSS United events for at least 6 months now? Okay. So yeah. Okay. Can you just share about what you think FOSS United is and like what they are trying to build?
From my understanding, FOSS Meetup is trying to create a community where people who are interested in FOSS related or with general technology related stuff could come together and discuss stuff. Like last time Subin had a talk, Subin and Mufid, yes, Mufid. So like they were from a random chat in WhatsApp was able to build and further things they were able to build Malayalam in script for Windows. So such conversation could happen here and such new problems can be solved. So that's what I think possible is right.
Interesting. How about like what do you think the FOSS United mission is, like from your experience?
I'm just recording the screen.
Yeah. Thank you. So yes, it's about bringing people together first of all. Our networking ഉണ്ടാവുമ്പോൾ ഒരു synergy create ആവും. Like all jargons, but still. Like when people come together, you get new ideas, you get to brainstorm, you get to find new perspectives on things, you get to see new problems, right? And sometimes there's that whole gap, right? When people are working in their own silos, like when college students are working in their own silos with just academic perspective, they are not building building for problems that are like real world, right? They have their own like I don't know the concept, but basically horses have this thing that are put on both sides of their eyes, right? They can't see anywhere but in front of them. Same thing happens with college students or employees. We are trying to bridge the gap there. Huh? Fedora. Yeah, Fedora. ഇതെന്താ ഒരു സ്ക്രീൻ മാത്രം കാണിക്കുന്നത്? Oh, this is separate screen.
Mirror ചെയ്തോണ്ട് display. Very good.
Out of rate. Resolution കുറച്ച്
മതി. അതായത് ഇത് ഇനി വിൻഡോന്റെ സൈസ് ശരിയാക്കിയാൽ മതി. അതിന്റെ സൈസ് ശരിയാക്കിയാൽ മതി.
Okay, do you stand up?
But no.
Just wait. You stand there. I can't record it.
Now? Hello, other order than then it will be able to see me.
No,
also.
this is that.
Oh, you have to see the screen also.
It's not coming up. Just keep it up straight.
The back il vechalo.
No, this is fine.
സ്ക്രീൻ ഇങ്ങോട്ട് വരുന്നത് എങ്ങനെയാ?
No, that's good. It's working now. It's fine. Mine is
വീഡിയോ
fine.
നെഞ്ച് എല്ലാം ഓൺ
Hey, you're getting the video.
അതില്ലല്ലോ.
Video ninja വരുന്നുണ്ടോ?
Yeah, video ninja is coming.
So you need to share your screen.
No, it's
Gone?
it's gone.
Oh, okay.
വൈഫൈ കിട്ടിയോ?
Is your Wi-Fi connected?
My Wi-Fi is connected. Yes, it is connected to Elsa and Connect.
അല്ല ആ വീഡിയോ നെഞ്ച് മറ്റേ വിൻഡോ റിഫ്രഷ് ചെയ്താൽ മതിയോ?
On air ആണെന്ന് കാണിക്കുന്നു.
ഇല്ല അതൊക്കെ വെറുതെയാ. റിഫ്രഷ് ചെയ്തോ? വെബ് ആർട്ടിസ്റ്റ് അല്ലേ എല്ലാവരും ഹാക്കാണ്.
Sleep off with it.
Okay. Sleep off ചെയ്യണ്ട. All right.
Yeah, that's all.
I'll start.
റെക്കോർഡിംഗ് സ്റ്റാർട്ട്
like-
Wait, I don't know the record.
ലൈവ് സ്ട്രീം ഉണ്ട്.
Hey, do you want to go through the slides?
Why?
Riya's slides.
Boja? No, you start off with the talk.
Okay. Hi folks. So we were just talking about FOSS
ആ
Meetup.
ലിങ്ക് അയക്കും.
We'll talk about that later during our networking session, along with the break. But before that, I'll introduce myself. So I'm Devdat. I work at a startup called Bytebeam. We build software for IoT devices and building basically a
Devdat,
data
you have to
platform.
stand here. We're not getting
Right? Yeah. Sorry. So that's what we do at Bytebeam. About me myself, I've been part of the. Okay.
Wow. Fedora, right?
Oh, no, this is happening for the first time.
Yeah. Always happens in production.
Okay, I think
Okay,
I'll have to
hopefully
actually. How the hell is it still like streaming?
It's not.
Oh,
it's not streaming.
through
It's
FOSS.
gone through.
Okay, it's not through Firefox.
ഇത് വേലന്റ് ആണോ?
Yes.
വെറുതെ അല്ല.
അതുകൊണ്ട്.
Sorry for that technical problem.
ക്രോമിയോ ഉണ്ടോ?
Yeah, you can try Chrome.
Chromium illa.
ഇല്ല.
I only use Firefox.
ഇപ്പൊ എങ്ങനെ ഇരിക്കണം?
How about now? It's back.
Yeah, it's back. Yeah, it's back.
അൺനോൺ ബഗ്സ് ആയിരിക്കും. Yeah, set ആയി.
Okay. Yeah. So I was. Study draw.
Resolution.
ഇതെന്താ സാധനം? പ്രസന്റേഷൻ ആണോ?
Yeah, you didn't.
Resolution is
ഇല്ല പ്രസന്റേഷൻ ഉണ്ടാക്കുന്ന സോഫ്റ്റ്വെയർ ആണോ?
അതെ. അല്ല presentation അല്ല. This is for diagrams. But I use it. Okay.
Open source ആണോ?
Yeah. Excalibur is open source. Wait. Forgot to do that. But fine. Okay, I'll just show it as it is. Fine. Okay. So yeah. Other than what I was just speaking about, I do open source contributions, right? Like I maintain some 3 repositories, and yeah, it's one of them is called RumQTT. It's like pretty popular Rust library for doing MQTT. MQTT is like a messaging protocol. I will not go that deep into that concept today. I will be talking about Atomics, right? I'll be using the Rust programming language to illustrate some of the concepts of Atomics. But first of all, I think it would be a good idea to actually take a count, like a survey of how many people know multi-threaded programming. At least heard of the concept of multi-threaded programming, right? Yes. Okay, fine. Okay, so how many people have tried it? Tried actual multi-threaded programming. Okay, nice. So one of the problems with multi-threaded programming is, of course, that you're in 2 different separate contexts, right? And it might seem like these 2 contexts are running in parallel, but that's not the truth, right? The operating system is basically handling all of this in a concurrent manner, right? It's like one thing is happening at a certain point of time, it might just preempt it. Preempt as in it'll. Okay. Yeah, I don't think we'll be able to do Video Ninja today.
WebRTC problems.
Yeah.
I think it's really something to do with Wayland too.
Okay,
Microsoft
we'll just go ahead without Video Ninja. I think
Okay.
that's the only possibility here today.
Okay, right.
So Video Ninja is like the software that we are using to stream the screen, right? The screen that you guys are seeing here is being streamed live, and that's happening through something called Video Ninja. We are having some problems today.
You're having some
Yeah,
problems today.
my laptop is having some problems today. So sorry for that. Yeah. Yeah. So yeah. When you're doing multi-threaded programming, you have 2 separate contexts which are happening almost parallel in nature, but actually they are happening in concurrent manner, right? Like the processor is not going to run 2 things at the same time. It's like running one thing, stopping it within microseconds or milliseconds, changing to another context, running that. So it might seem like the thousands of threads that you have running on your computer are running in parallel, but actually it's like the CPU is giving them some time, changing to another task, changing to another task, changing to another, doing that in a very quick manner. So it actually looks like it is, but it is not really parallel. So that's known as the concurrency, right? And you're doing multi-threading to actually do concurrent tasks. Right? Not like even the processes that you have, like thousands of processes that are running on a computer are being handled in the same manner, and within these processes there are threads which are also being handled in the same manner. So that's like multiple levels of abstractions, right? The problem here is if you have 2 contexts, right, with data, right, you will almost never be able to guarantee that the data that you are having there is safe from being corrupted because of all these switches, right? Quick switches that are happening. Just let's take an example. What might be a good example of a concurrent process? A very heavy concurrent process, like too many concurrent events.
Web server?
Yes. Like let's take the example of Facebook, right? How many users are trying to log on to Facebook at a time? Instagram. How many people are trying to log on to Instagram, right? That's like at least 1 million people who are trying to log on at the same time, right? Every second or every millisecond even, right? So you'll be seeing these events that are happening in a web server that are just too fast, right, to even take into account. But these web servers handle them with ease. How do they do that? Well, they use Atomics under the hood, right? So this is just like a teaser. You have to learn most of it yourselves, but today I'm just going to go through some concepts that will like at least open your eyes to the importance of Atomics, right? Okay. So first thing first, even before we go into my slides, I just have a quick question, right? How many people had the question in their mind right now that why is he not talking about mutex? Why is he not talking about like reference counts? Why is he not talking of all those things, right? All those concepts. Like, any idea why I'm not talking about those concepts right now? Anyone? Like, anyone, just raise your hands. Just take a guess. Nobody here knows the answer right now. Just take a guess. Quick guess. Anyone? Why am I not talking about locks? Why am I not talking about mutexes? Why am I not talking about in the context of multi-threading? Why am I talking about atomics here? Okay, I guess I'll have to answer it myself. Fine. That's because all of them are actually built with atomics. Interesting, right? So your mutex, your locks, your reference counts, everything under the hood is actually atomics. Right? So if you have like a shared memory object between two threads, right? You have to ensure that those objects, right? Let's say you're just not going to mutate it, right? You're not going to change the value of that shared memory, right? That's known as immutable shared memory, right? For that you just need a reference. But still, the problem with having references to an object between two threads is that who owns that object, right? Why do you need an owner? Because the object needs to be freed, right? Otherwise it'll leak into memory, and then basically you'll never throughout the duration of the process that memory will be basically lost. The operating system won't be able to free it. Your process itself doesn't know that it exists now, because who does it, right? So for that we use the concept of reference counting, right? And in Rust there is something known as the atomic reference count, the ARC. It is implemented with atomics. It is being used to handle memory in a multi-threaded context. How about mutexes, right? So what is a mutex? A quick answer. You have same thing, right? Reference in memory, but then that reference should like the memory object should be mutable. You should be able to change it. Let's say you have a database, right? A database can have multiple users at the same time. Multiple threads could be mutating the values inside of that database, right? How do you allow that? Each object is kept inside a lock, right? Each data value is kept inside a lock, and that lock is basically operated by using atomics. What do I mean by that? You have a value there. You are saying you have a consumer at this moment. Consumer is just a reader. How about a producer? Producer is different. Producer is creating that object, right? So producer should be able to mutate that location in memory. So they should be saying, if there is a consumer, you can allow multiple consumers at the same time. Multiple people can read an object at the same time. It's not a problem, right? But then when you have like a writer, somebody who is trying to mutate that value, you need to be able to say, stop. Nobody can read this read at this moment. Nobody can write at this moment. Only this one person who wants to write will get to write, right? So that's the whole concept of locks, or at least read-write locks, mutexes, right? Yeah. So atomics is being used here, but then why did we have to actually use atomics, right? Like you could say that there's an like the processor should give us a guarantee that whatever you're doing at this moment is actually happening in a very strict pattern, right? Where it does not break things, where it does not corrupt data. But that's not the reality, right? The reality is that when you give your code to the front end, the compiler front end, it optimizes it, and it outputs something known as optimized IR, or internal or like intermediate representation, right? That's code that again gets transformed into optimized machine code by the backend. And this machine code is what is actually getting run on your CPU. But here's the very interesting new revelation, right? The CPU actually optimizes that further. Right? Let's think about a CPU example here to understand what I'm talking about here. Right? Optimized instructions inside of the CPU. Any idea what it could be? Just raise your hands if you have like a decent or a simple idea of what problem might happen there. risks is, but yes, like what could be the problem here?
Machine specific ആയി മാറും.
Hmm?
It will be specific to the machine.
No, like, but why do we need atomics there? But along with that, yeah, you're going on the right direction, but
All this has to be shared.
okay, so in the CPU, right, that's the concept of caches,
Basically, it's a lot of
right? You have like, ever heard of the concept of cache? I'm just going to skip over some concepts, of course, because we don't have the time. It's just 30 minutes here, right? So inside of a CPU, there is 3 layers of cache sometimes, right? Sometimes just 2, sometimes just 1. But usually you expect that to be like 3 layers of cache, and then after that is your memory, right? So the CPU will be running so fast that it does not want to wait for new data to come in. So what happens if you have like operation where you're saying A, let A is equal to A plus B, and the same time there's another another core in the same CPU that is also doing a calculation like let B is equal to A plus B at the same time. Are you seeing the problem here? Huh? They might end up with the same value, they might end up with corrupted, like different values, they might end up with God knows, right? Like we cannot guarantee what will happen here. This is kind of an undefined behavior, right? You're getting the problem now, right? You have 2 cores running on the same problem, running on the same variables with different operations, ending up with very different values with every run, right? So one run you will get one value, one run you will get another value. Sometimes you might just like cause a fire, I don't know, right? So that's how we wanted to like that's the problem that we wanted to solve with atomics, right? When it was first proposed earlier in 20th century itself, like end of 20th century is when atomics as a concept came in, wherein it started with the concept of locks inside of the CPU itself, right? So lock, any idea what that might be? It's the same concept, right? The same concept that you're using in a program, right? It actually is part of the assembly now. In the assembly you're saying this operation, just ensure that the data values, that underlying data values are locked, right? That no other operation happen on those values at the same time, right? It gets converted into machine code where the machine itself is told what to do, right? Fine. Okay, that was locks, and then more concepts came in, right? Yeah, we are not going into the processor today. I'm not going to explain what the processor is actually doing here. We don't have the time, of course. Anyways, so yeah, in basic sense, atomics is just guaranteeing that an operation is undividable, that it's either going to reach a complete stage or it never happened, right? Which is the same thing that you see in acid, right? Have you heard of the concept of acid? Atomic, consistent, isolated, right? Yeah, same thing. That's what's happening here as well when we are talking about atomics. But this is happening inside of a processor instead of a database, right? Very different things, but similar concepts. Fine. Yeah, as I said, we are going to be talking about some Rust things, right? So how many people know of Rust? Okay, that's a fairly low number, but fine. How many people have used Rust? Oh, interesting. That's like the same number as people have known of it. Very, yeah. So like, you guys really try out the stuff that you hear about. Fine. Yeah. So locks can be used to control objects that have variable size, right? not inside the processor, I'm talking about the general concept of locks inside of mutexes, inside of your C, C++ or Rust programs, right? You can use it to control, manage control over variable size data objects, which includes structs, right? You have like a record. Understand the concept of record, right? You have multiple types of data that are packed together in same location in memory, right? That's known as a record. The same concept as a struct in Golang or Rust or classes in C++, right? So yeah, Atomics has a very strict requirement that the type size should be known, and it should be restricted to the size that is allowed by the underlying platform, right? So you'll see that Atomic 128 is not a general type. It's not that well supported. It's only supported in 128-bit CPUs, right? And Atomic i64 is only supported in 64-bit CPUs, and so on, right? So yeah, that's the concept here. These are actually being implemented in your code, getting unabstracted, like de-abstracted into actual assembly or machine code that can get run on your CPU, and it's guaranteeing it at that level, right? Where even inside of the processor, optimizations are not corrupting your data. That's the whole thing behind Atomics. And what you're seeing here is just abstractions on top of it that allow you to write code that is simple to read, right? Easy to maintain, and extremely tough to understand. Yeah, abstractions have really corrupted the whole concept, the whole study of programming for like the entirety of its existence. So it's also a boon. Like, it helps people who are just out of college to write software that really improves lives of anyone who's impacted by it, right? Like a college student building something like I don't know, like a DNA mapping software, right? It's helping solving problems like cancer. Why would we call that a problem? But then underlying implementation problems happen when you don't have the resources. That's when you have to actually dig deep and find out how to solve those problems. Like, this is one of the tools with which you can solve that problem. Fine. So let's talk about the different atomic types, right? There's atomic bool. Very interesting to note that it's actually not a bool. Like, a bool is supposed to be 2 bits, right? It's either true or false. But actually it's implemented as a U8. As a byte, right? An 8-bit value as a I8 here, atomic I8. The same thing is what's underlying atomic bool, and that's because the CPU just could not understand the difference. It only operates at a byte scale, so true, false, but still actually like 8 bits.
എല്ലാ ലാംഗ്വേജിലും അങ്ങനെയല്ലേ?
Yes. It's the same thing in all languages, but it's actually supposed to be just 1 bit.
Right.
Fine. Atomic I8, and then there's like atomic I16, which is just twice that length, right? 2 bytes, 1 probably. And then there's atomic I32, which is 32 bits, 64, even more. I size, right? Anyone who has a understanding of what I size could be?
Future processors?
No. So I size is actually just the same as I64. It's just saying that whatever is the size of the largest size of the underlying platform, allow that, right? Size is basically saying the same as the address space size.
Do we really have 128-bit processors at the moment?
No, the problem is
There are, of course.
No,
Atomic, like I30, 128 is there. The processors.
No, the thing is that in the Linux kernel, what happens is that even if we have 64 bits, when you check the address space that is actually allocated might be only 39 or so, because by default they give around maybe 8 terabytes of that much space. So that is why they have this. Otherwise, if you go for 64 bits, it's a waste of space, right?
Right.
So like when you do uname, you can see that the address space will probably, I think the default is for 39 set in the kernel.
30?
39 bits or so. There's not 64 bits.
Oh.
Even if you install a 64-bit OS, Linux by default is only allocating 39 or so bits for address space.
Oh, right.
So that is
there should be a lot of
TLB.
exactly.
memory
It'll
space.
be it'll be.
Okay, fine. Yeah, atomic bool, I8, all of those we just talked about. So what's the difference between I and U? Right underneath you can see U8, U16, right? Those are just the same things. Like like one is integer type, the other is unsigned integers. One can have like negative values, the other can't. That's just the difference. In between you can see an atomic pointer, right? Rust actually does not allow you that much of control over pointers and all, but then you can just get into unsafe land and you can do a lot of trickery and stuff like that. You can with atomic pointers, you're just saying that there's a pointer there. You can change the values. You can play around with it. Fine. Okay, and then once we are done with this, right? Let's actually look into one of those values. So atomic bool, right? Inside atomic bool, you can see that you can create a new bool, right? Which could either be true or false. Then you can also like take the atomic value from a pointer. Yeah, you can get a mutable value to that. You can create some from a mutable value. All of that is there, but what's most interesting to us is this loop, right? So what are we doing here? You have some new bool value, right? Just having the value true. We want to take the value that is stored inside of it and check if it's the same, right? True. So that's what's happening here. So you're saying some bool dot load with the ordering. We'll talk about what ordering is next, but you're saying there's a relaxed ordering, and then we are checking if the value that we have just loaded now is the same as the true value that's asserted against, right? Then store. So these are all operations, by the way, just so that you are understanding what we are doing here. We are going through some operations. Okay, this is actually like very dull, right? The screen. Are you able to see the screen? You're able to read it, right? Okay, fine. It's like from here I am seeing a very dull screen. Anyways, so that's the store operation, which allows you to change the value that is currently held in it. So you can see that there's a value, then you're storing the value false over there. True, you're swapping with a false value there. And all of this is happening with the ordering relaxed. We'll talk about what the ordering is, but let's swap also. Right? You take the value currently held, you change it with another value, and then the operation returns the value that is currently held in it. So that's what's happening there. Compare and swap is actually deprecated, so it's better that you don't use it. Still, what does it do, right? It has three parameters here, you can see, other than itself. It's current value, new value, and the ordering, right? So if the current value is the value that is currently held in it, it will do that next operation, the swap operation. Otherwise, it will return false, right? That whatever value was expected to be there is not the value that was found there, right? So why could this be helpful? Compare and swap. What could be the possible reason that it might be helpful to have a compare and swap operation inside your code? Any guesses? No, like take a like.
If it's stored, fit to swap.
No, take a example from real world. No? Like,
If it is already true, don't do it again.
it's the opposite of that.
Oh, if it is only different, then do it.
No, current value and new value, different things.
Right.
Yeah, you're saying? Sorry. No, take a real world example. No. Oh, screen. You're talking about the screen. Okay. How do I? Okay, fine. Okay. So yeah, I was just saying that compare and swap could be very helpful when you are using a database, right? What could you do there? Let's say you are going to say to the database, right? My salary, right? Add 1 lakh to it. Who would not want to do that themselves, right? But then what if HR is doing HR is doing the opposite at the same point?
Okay.
Right? So that's the whole thing happening here. Like underneath, you might be taking a value, you might be updating it, you might be putting it onto the into the system, right? When you wanted to do x plus 10, and then same time someone was doing x minus 10, that can be two things that could happen, right? It could become x plus 10, it could become x minus 10, it could become x. These are the three different states that it could end up in. But then we don't want that to happen, right? We want to say that if somebody is doing it should always be x at the end of the day. That's the desired result, because somebody is doing an operation, somebody else is doing an operation, both should not corrupt values, right? Somebody should not hide the value that the other guy gave. That's what the compare and swap operation is doing. It's saying, at the moment that I took this value, I saw that its contents was x, right? When I did the operation, I came back and tried to load this new value into the database. I saw that the value had changed. So my operation failed, right? It could not it could not change the value. So what happens there? Like, what do we do then? It should fail, right? That's the whole concept behind compare and swap. But it's deprecated because obviously there's like problems with it, and we moved to something called compare and exchange. Like that's the whole documentation is very well written. So if anyone wants to read about atomics, just go through the standard library documentation and you will be able to learn it pretty quickly. Otherwise, you could just go and read this book, by the way.
No.
If you have the time. Like I read it in like 2 weeks, so it's not that like that complicated.
But isn't this already a solved problem in other languages, or is this a new thing?
A solved problem as in?
As in because this
This is a tool. It's not a problem.
Yeah, because why would they need to deprecate it if it's already a solved?
It's not a so okay.
Right.
So compare and exchange did not used to be the what do you say? It was not the right solution at a certain point of time.
Right.
It became the right solution when people figured out that it was the right solution. That whole journey of when people were going through it, Rust had already adopted the compare and swap. Then when they ended up figuring out that even processors were going to standardize on this exchange, compare and exchange, that's when they also figured that they'll move to this. Like 2015 was when compare and swap was introduced. Compare and exchange was already in the being standardized by 2018. So like they figured that by 2020 they should just directly shift to compare and exchange. So yeah, there are two, compare and exchange and compare and exchange week. We'll next talk about that. But then compare and exchange is basically doing the same thing. It's just saying that if the current value, just the difference is you can see obviously here. There are 3 values. There are 4 now, not just 3. Right? Current value, new value. There's a success ordering and there's a failure ordering. Right? What happens when the failure happens? Like how do you handle that? How do you handle memory in that case? You can say, so usually you can see an example that right underneath. Failure ordering is usually set to relaxed. You don't care about failure most times. Sometimes you could just say it has to be acquired, right? Acquire ordering. What are ordering? Let's go into ordering, right? We have already talked about ordering a while. We have not actually understood it. So yeah, this is the final concept in atomics. Before we get into the code, do we have the time for it? Yes, we do. Okay, fine. Wait, I'm going very fast now. No, actually,
No, we started
after
10:50.
my time. Yeah.
We started
Okay, sorry. Yeah. So ordering, as you can see, there are like 5 types, right? There is relaxed, release, acquire, release, and then sequential. Yes, I'm forgetting. Sequentially consistent. Yeah. So yeah, I don't use sequentially consistent. At most I use acquire and release. Right? Sequentially consistent, yeah, it's similar to acquire release, but it has additional guarantees that everything will be sequentially consistent, as in the sequence will be in the same order, right? I should have prepared for this, but I did not. But okay, inside of your system, what happens during memory ordering is that it's guaranteeing something known as happens before, right? It's there in the book. I can't show the diagram right now, but basically
Reminds me of college a bit.
sorry. I failed. I failed you. Anyway, so inside of atomics, that's the whole guaranteeing of this thing called happens before. Happens before. The English words, right? Something happened before this. That is what we are trying to guarantee with atomics memory ordering, right? So yeah, that's like three very important things here. That's relaxed, which means actually no consistency happening, no constraints on how the happens before should be. Two threads could basically just jump around, one could happen before the other. Whereas with release, you're saying that if I'm storing some value here, some other thread should be able to load that value from there, right? That's the happens before guarantee that we are telling the compiler as well as the processor to maintain when they are executing this code, right? And then how about acquire? Acquire is opposite, right? It's like whenever I'm trying to load a value from here, guarantee that the release has already happened on this value. And if those two are not happening in time, like one is happening after the other or the opposite, those guarantees need not be guaranteed. It's just that if it's happening in this order, this value should be available for this guy to take out. That's all being guaranteed by the underlying execution within the CPU. Yeah, so that's it for the theoretical example. Let's just take a look at some code. I'm not sure if I'll be able to implement it in such a way that it makes sense in this short time that I have, but fine. So if self dot inner, the inner, by the way, I just so nervous right now. Yeah. So if you can see here, there's a structure called lock, within which there's an inner value, an atomic bool, right? So we are taking the atomic bool as the basic type on which we are going to implement our code, right? There's a lock operation and there's an unlock operation. What happens during the lock operation? Whenever we say lock, we have to just load the value inside of it. We'll be using the ordering release, relaxed, right? Because we really don't care about who gets to run first. We just want that value, right? So if the value is currently true, right, which means the lock is held by somebody else, in that situation what we need to do is we need to say we can't do anything, so just drop, right? Don't give anything. We could also just say here, sorry, we could actually print something here. Yeah. By the way, the whole live coding thing, Mark's suggestion. So if you're thinking this is boring, blame him.
I can't understand anything unless I see code.
Yeah. So we'll say the current value, right? We just figured out that the current value is true. So the current value is not true, which is why we are in this else block session. Not using else because that's how you write code. If you have a return, you need not write the else section there. But fine. Here you are saying that while self dot inner value dot compare and swap or compare and exchange, right? We want to do compare and exchange. Okay, I forgot how to go down. Sorry, compare exchange. So the current value we know is false, which is why we are in this branch, right? Right, and we want that we want to set the value of this to true, right? And how do we handle success, right? We just loaded a value, but then we stored a value, right? So this is supposed to be a release ordering. Yeah, and failure we really don't care, so we'll say relaxed, right? And why do we need a while loop here?
We will wait for it to get.
We'll continuously do this until the value
lock.
actually turns out to be true, right? So it's a print this is already locked, and then here we'll say locked, right? We need to print a new line also, so we'll do that. The unlock operation should be the opposite. Like, theoretically it should be the opposite. What are we trying to do here? Is saying if, not if, while, actually we need not do it. Can we just directly set the value? We could. Yeah. So we'll say self dot inner dot whatever is the current value here underneath. We just want to change that value, so we'll say store, right? What is the value that we want to store here? It's because we are just leaving that lock, right? The ordering, of course, what should be the ordering here? We are storing the value.
We need the lock first, right?
What do you do when you have to order something according to a store?
Acquire.
No, it's the opposite. Acquire is when you're taking the value, loading the value.
Right.
When you're storing the value, you have to relax it. Sorry, release it.
But that is after the process, right?
Huh?
When you want to write it, you need to first have the access on it,
Hmm.
and then you release it.
It's already acquired.
It's okay.
The value was acquired by you last. Nobody will be able to change that value during the duration of your lock holding.
Okay. Then after that, what's the things to do? Then we will release it. Okay.
Okay. So, right, and right after this, we'll just wait. Let's write some code, right? So here I'm saying I have a lock value. I forgot.
False.
Since this is a value, how do we share memory? We just directly hold a value here. Fine. Lock inner. The inner value will be an atomic bool. Default value is false. Yes. What happens when you set it to true? Any ideas?
Stuck in it.
It will forever be in that state. It never unlocks. Yeah. Yeah. So let's say we have two threads. The main thread is main thread. So main thread will say lock just whatever is here. I want to lock it. Right. Just thinking about how to emulate it. Okay, let's say this should return a true or a false value. So here we could not get the lock, so we'll say false, right? Here we were able to get the value, so we'll say return true, but we just write it as true. right? In Rust, that's the simplicity of the program.
Also Ruby.
Oh. Shitty.
Ruby. I think it was copied from Ruby.
Probably.
If lock.lock, right? If we were able to get the lock, we need to also we'll sleep for a while, so that the other guy does not get the lock in milliseconds, right? So we'll say duration from seconds 10, like 10, yeah. And here we'll say print the lock, right? Otherwise we'll just quit the code, right? We'll just leave. Like anyone who has a cricket bat, went to play in their childhood and then they lost, just leave. Yeah, after the sleep,
ഓ സെമിക്കോളം വേണമല്ലേ?
yeah. Lock dot, yeah, you have to unlock when you have the lock, right? Otherwise the other guy won't be able to do that. Yeah, you need to just copy this code. So
ഓട്ടോ ഫോർമാറ്റർ ഇല്ല റസ്റ്റില്, ലൈക്ക് സേവ് ചെയ്യുമ്പോൾ തന്നെ?
it does exist, like, but I don't like to use it. At like you could tell nvim to do it for you, but then I don't like it.
ആ സാധനം സെമിക്കോളൻ ആഡ് ചെയ്യോ? ഫോർമാറ്റർ സെമിക്കോളൻ ആഡ് ചെയ്യോ?
It could.
It could do.
Yeah, so lock dot unlock, right? So okay, go.
ടെർമിനലിനകത്ത് വിമ്മിനകത്ത് ടെർമിനൽ.
You can do that.
Yeah, what are they going to write here? Run the example. Not no. Let's see. What did I name this one?
Atomics.rs.
Okay, wait.
Of course, the annoying compiler is here.
It's not annoying. It gives you good readbacks.
Oh, okay.
Nice.
I had to.
Okay, let's see.
Yeah.
വന്നല്ലോ വനമാല. ഇതോടുകൂടി ഞാൻ റസ്റ്റ് നിർത്തിയത്. കമ്പൈലർ ഭയങ്കര അനോയിങ് ആണ്.
Hey, compiler gives you great.
അങ്ങനെ പറയാം, പക്ഷേ humans important.
Have you read the C++ compiler?
Yes, yeah.
What can you understand from that?
അതും ശരിയാണ്.
Okay, I have to move. Fine.
സെഗ്മെന്റേഷൻ ഫോൾട്ട് കിട്ടൂല റസ്റ്റില്?
കിട്ടും. But very, very less.
Like it's suggesting what changes you have to make,
Yeah.
right?
Right.
Like what's better than that?
AI ഉണ്ടല്ലോ.
Let's not start with that.
Okay. I'm really sorry, Eric. I can't do live coding.
Yeah, I think we'll stop. I think we got to go back to your vlogs.
Okay. So yeah, that's because we are moving around contexts. What we could do here instead is we could say, what was it? Scoped.
ഇതിപ്പോ ചെയ്യുന്ന വെച്ചാൽ ത്രെഡിലും ലോക്ക് ഉണ്ടാക്കാൻ നോക്കുന്നു, മെയിലും ലോക്ക് ഉണ്ടാക്കാൻ നോക്കുന്നു.
You need not move in that case. So this should work. It has to take the scope.
Yeah.
How do I give the scope though? She is expected to take one argument.
എന്തെങ്കിലും ആർഗ്യുമെന്റ് കൊടുത്തു നോക്ക്.
Huh?
പാവം ഒരു ആർഗ്യുമെന്റ് ചോദിക്കുക.
It's asking for the current scope. So I have to get the current scope. I have to give it to the underlying closure, and it's not complicated that much.
റസ്റ്റല്ലേ കോംപ്ലിക്കേറ്റഡ് ആക്കണ്ടേ?
Yeah, we just need to atomically reference count it, which is that's why.
ഇതൊക്കെ സിയിൽ സി പ്ലസ് ചെയ്ത അവസ്ഥ ആലോചിച്ചോക്കെ.
ഇത് അതിന് എളുപ്പം
അതിലെളുപ്പം
എളുപ്പമാണ് എഴുതാൻ.
അതെ ഞാൻ പറഞ്ഞില്ലേ
ഡീബഗ് ചെയ്യാൻ എളുപ്പമല്ല.
കുറച്ച് കഴിയുമ്പോൾ പഠിക്കും.
പിന്നെ സെഗ്മെന്റേഷൻ ഫോണിന് ഡീബാറൊക്കെ തലയിലായിരിക്കുമല്ലോ.
ഇത് കാണുമ്പോൾ മനസ്സിലായി എവിടെ നിന്നത്.
Let lock2 is equal to lock.clone.
But the messages we get on Rust is much more verbose and we can understand it.
Hey,
C++ and Chamber we had to do OCD, on-chip debugging.
Mark will give you the best reasons why. He has been working in regular C. Okay. Yeah, don't even try to understand what I'm writing right now.
Okay.
In C we don't even compile. We start off with GDB. GCC लोट बोले GDB
I'm really sorry.
No, sometimes GDB will separate run out.
Oh yeah, of course. We don't need to.
No, once more or less it does this. Yeah. I never started GCC.
Wait, we don't need to make it clone because we have an arc reference to it. Yeah.
I think it's good enough, man.
Oh,
We
yeah.
got the
Gist, right?
Yeah, just we got the gist of it.
അധികം പോയ റസ്റ്റിന് ചീത്തപ്പേരോ.
മതി.
I'm really sorry.
Now we get like 5 or 6 people to come to the meetup.
Yeah, this is the final. If this does not work, no reason why I should continue. Hey!
Yes.
എന്തുണ്ടായേ?
Compile
ആയിട്ടുള്ള
Oh, it actually does not print anything.
Yeah. Look, check time.
10 സെക്കൻഡ്.
That's the reason.
Oh, 10 seconds. Okay.
Yeah.
Siri.
All right. Saved.
Yeah. Alright guys, thanks. Thank you for listening to me. Yeah, if anyone's interested in Rust, join our community. Not everything is as complicated as this. Yeah, thank you.
What's the next one? I don't know.
DevC, right?
FC?
ഡെസി ലാസ്റ്റ്.
Last one.
Where's the
Oh, you're next. Okay, right. Oh, how are they sharing the link?
Telegram? For Video Ninja?
No, I think
Yeah, let's just drop Video
will work
Ninja.
with us. It's because Fedora Wayland was on.
Windows.
No, it will work. We'll work.
No, how do I share the link?
We'll do that.
ലിങ്ക് ഷെയർ ആണ് പാടും.
No, I'll type it in.
Laptop work ചെയ്യില്ല.
അത് ശരിയാക്കാട്ടോ. പറഞ്ഞാൽ വിചാരിക്കണം ശരിയാക്കാം.
ഞാൻ ആലോചിച്ച ഇതാണ്. പക്ഷെ അത്യാവശ്യം അതുകൊണ്ട് ഞാൻ
ഇല്ല അതാ ജാവാസ്ക്രിപ്റ്റ്
A few testing, right?
Yeah, few too. Hey, sorry.
ഒരു 30 സെക്കൻഡ് വന്നാൽ ശരിയാക്കി തരാം. സഖാ വന്നിരിക്കണ്ട. ഇതൊരു ബഹളമായിരുന്നു. മലപ്പുറം കത്തി
ലാസ്റ്റ് രാഷ്ട്രീയക്കാർ കൊണ്ടുപോയില്ല.
ലാസ്റ്റ് ക്രെഡിറ്റിലടിച്ച് മാറ്റി.
Yeah, I guess.
ഞാൻ
As long as you're in view of this.
ABP മറിച്ച് പറഞ്ഞു ഞാൻ കാരണം. ഞാൻ നോക്കുമ്പോ ഒരു ദിവസം ഇവര് വിപ്ലവ നായകൻ.
ഇന്റർവ്യൂ ഉണ്ടാവുന്നത് പക്ഷെ അപ്പഴത്തേക്ക് പാർട്ടിക്കാർ കൊണ്ടുപോയി.
ഇവൻ NITയുടെ ഗേറ്റിനവിടുന്ന് കൈ
Just a minute, huh? Let me just see if I'm also getting through. Yeah, I'm also getting, so I'll record. So what's the next talk? Shit, sorry.
I know.
What did it do?
You just drop it at the
No, it's fine, just let it record. Alright, we can get started. So the next talk is by Aditya from Litmus 7. Alright.
So this is my first time not just taking a talk, attending a FOSS Meet event. So the name's Aditya Nandakumar, and I'm working here at Litmus 7 only. So Litmus 7 is a company focused on the digital future of retail. So we deal with IT, specifically in the retail industry, in the wish fulfillment industry.
അവിടെ ഓണാക്കാം. ഒരു സ്വിച്ച് ഉണ്ടാകും മുകളിൽ അത് ഓഫാണ്. ആ ഒരു റെഡ് ഉള്ളത് ഗ്രീൻ ആക്കണം.
Can you hear me? Yeah, so I hope you heard what I said before. So again, working at Litmus 7 only. So we deal with digital future of retail, basically IT solutions for retail and wish fulfillment. So I'm an associate engineer here, just joined here, not even completed an year here, to be honest. So I'll be talking about high performance applications, or specifically high performance web applications. I should have been more specific. And so what is high performance in the sense? So with web applications, we all know what is the experience using web apps, or just any websites in any websites actually. So it will be slow, it will take a while to load. Whatever operations we do, we'll be stuck at white screens before we even get the first UI to print. So I won't be taking a very technical session. I don't have a live coding session and all. I'm just giving you. So I am.
What are the lights?
They were not excited by the
lights did not like me, I think.
live coding.
The lights knew me too well. So yeah.
Lights wanted live coding.
Okay, now it's better.
Yeah.
Okay.
Oh, that's too bright.
The machines are taking over.
Yeah. So I'll not be so I'll just be taking a general view, a holistic general view on how to write, or not to write, how to design high performance web application. A few tips per se. So the title started with I am speed. So this was a reference to Lightning McQueen saying I am speed. So my idea was comparing applications to being fast as Lightning McQueen, but unfortunately, me lacking experience, having chosen quite a big topic, I instead of the application itself being in the place of McQueen, I find myself in the place of McQueen, having to complete this as fast as possible within the 15 minutes allocated. So yeah.
No, you can go over time. We don't have.
It's fine. So let us understand latency. So let us look at what latency is for a web application. This is a way oversimplified view. So we'll have a client, your browser, your phone, laptop, wherever the client, wherever the browser is running, you'll be sending a request to some server. You'll be getting back the response. So the time it takes in total will be whatever time it takes to send the request to the server, the time it takes for the server to process it and send it back. So this is the way oversimplified view. But what is actually happening underneath? So is this just what is happening underneath? All the backend, like any web developers here, backend or frontend, they will be knowing that no, this is not as easy as it gets. So this is something. So again, this still is a way simplified. It's not. So even this is a simplified view of something, of what it would really be like. So this is an example of a microservices architecture. So you will have a client. You might not be directly hitting the API gateway. Instead, you might be having a API proxy or not proxy. Then that will be hitting the API gateway. And I don't know who have seen this. There is a very popular YouTube video called Microservices by a like it's a comedy skit on how microservices design is. So
Fireship.
not a Fireship. It's a comedy sketch. I forgot the channel name. Anywho, so to get something, so you might be looking to get orders of a user. So you will might have to hit the customer SVC service first, which will go and query the order SVC, which will give you back the product IDs. But you then need to get the details of the product, the image of the product. So you will go back to products SVC again. So there is a lot of communication happening there, and each of them will have to hit the DB for those data. Some will be cached. So there are optimizations there, but it is a big system underneath what all abstract apps or UIs that we are seeing. So when we click buy on Amazon, or when we click post on Instagram, there is a heck of a lot of things happening in the background. So we might be the main cause of latency for most applications that we use is just our network ping. So contrary to what people think, actually servers, even if you code them in Java, actually I started my microservices development in Java. I can already see Subin trying to throw things at me for saying Java here. But yeah, so even if you write them in Java, which is not, it is definitely not known for being a very fast language.
Better than Python.
Yeah,
Right.
that is that. So especially with Graalvm. So even if you code them in Java, the still not majority but a significant part of latency for your application will still be in the ping. So if your server is, for example, in US West 2, so US West 2 or US East, there is where you have deployed your AWS. So if a user is hitting from India, it will take minimum 100 milliseconds just to ping to US, right? Whatever time it is in actuality. So you could look at things like deploying at multiple locations at edge, deploying at edge, runtime, edge functions, whatever the new things are there in nowadays. But still, then you will be having database only in one location. Otherwise, you will have to look at distributed databases. It's a whole mess. So it gets really hard, right? So I won't be talking about it. So that is there. So this is things that you need to focus at first. But what I am going to be talking about is very particular. So I'll be looking at how to increase performance here. In the first of all, in the backend layer, how to increase your performance here. So let us start. So I took a example of a microservices architecture, and that is what I am going to be talking about. So particularly high performance microservices. So initially my talk entirely I was planning on taking high performance microservices as a whole, but then I kind of decided no, I'll just take a broad view, just not get into the architecture of the code that much. I'll just give you a broad look into how things are. So why I took a microservices example. So if you are building a simple web app, calculator, not a calculator, something that uses a simple notes app, say you are building a simple notes app, you actually don't need to think about backend performance that much actually. So whatever you build, it is going to be fast enough for most users, right? And with microservices, one of the things that comes into play is the intrinsic overhead that comes with inter-service communication. So that will always be there. So we'll be looking at how to address that, and where microservices are used. So again, lots of people actually like to hate on microservices for its overhead, whatever the design complexity it offers. The designer of Rails, I believe, yeah, yeah, he has an article, the majestic monolith, saying the benefits of monolith and the modular monolith approach. But there are certain cases, so it's like there are certain cases where microservices is good. So if you don't use it for that, if you think microservices is the only solution, you are going to have a bad experience for it. There is a lot of overhead in development and during runtime as well. So, but there are certain situations where you need that kind of live scaling. So again, coming back to the example, I know for e-commerce applications, there are going to be season sales, there are going to be flash sales where you will need to ramp up certain parts of your application quite quickly. So microservices are kind of the best at that. Yeah. So and definitely it is not because that is the thing I work with. That is not why I have chosen microservices as an example. So coming back to it. So again, this is kind of a very small example still. For microservices is not what you would see. You will have in double digits number of microservices for a single platform maybe, right? So how do we aim to, or how do we look at increasing the performance? So how, from the point that the request comes into your server, how do you increase your performance there? How do you decrease whatever processing time it takes? And we'll start with language barriers. So again, coming back to how I started microservices, it was in Java, Spring Boot. I don't know who all have experience here using Spring Boot, and we were talking about language abstractions before. So if you have used Spring Boot, despite all maybe performance issues it has, it is a pleasure to work with. You don't have to do anything.
Yeah.
There will probably be annotations for everything. You will have a couple of lines of actual Java code and 15 lines of annotations, but it will work. You will get what you want done with it, right? But you have to look at developer experience and you have to look at actual user experience. So those don't go hand in hand all the time. So you will just use a faster language. And there are people, when you say that, who go like, why don't you program everything in ASM? That is what some people ask. There are people like that, but there is always that guy. We all know that guy. Yeah.
Anyone heard of Carmack?
Yeah, John Carmack.
Yeah. He built Doom in ASM.
No, it was C, I believe.
Huh?
C. He wrote C, the inverse square root algorithm. He wrote that. It was in C.
He wrote it in ASM.
Yeah. Roller Coaster Tycoon. That was written in. That was written in.
That is not him, right?
That is not him.
Yeah.
That was written in assembly. Doom was written in C, I believe. So anywho, we all know that guy who goes like, oh, why don't you do this? But it is not always easy. So imagine a beginner developer, someone tells him, oh, why are you writing in Python? Choose a faster language. He'll come search fastest languages programming. Java.
Last താഴെ പോയി.
Oh my god.
Rust is the last year.
Hey, it's still there.
It's still there, right?
അയ്യോ റൂബി അവിടെ.
You should all remember this when you search for something in Google.
So fastest is based on context, no? JavaScript
Yeah.
and Python, obviously you can just pull up. It's like
Yeah.
developers.
Yeah,
can do it
developer
fastest.
experience, it is going to be real fast there.
ഇതേതോ
So
clickbait article ആണ്. അത് നോക്കണ്ട.
so
Just
just keep this in mind, not while you're programming, but when you're looking up whatever like medicine disease symptoms you have in Google, this is, so you will get take this medicine, it will be some, like, yeah, that time we don't have context, but now we do have context. This is something all of us know, right? So it is not easy. So if you're looking at again microservices architecture, this is one of the benefits with going with microservices, is that you don't have to rewrite the entire thing. Some services will be hit more than others. So you can choose to rewrite just certain parts of the application into faster languages where those are taking up more resources or are being a bottleneck to the rest of the system. So you could go with Go. So I am a Go developer now, or just started here a couple of months. I was going to say Rust, that's why I had the logo here. But after I saw the demo, I think this is going to be better. Just kidding, just kidding. Rust has its benefits. It has its like features, like exceptionally fast compile time. Yeah. But yeah, so there are other options for it, and you could change. So catalog service is good. So this is again an e-commerce example, and you can see like catalog service is one of the things that is going to be hit the most, because users will be logging in, seeing the home page, which will always hit the catalog service. There might be recommendation service. So again, simplified view. So you could choose to rewrite just that part and Go or something else, or try to optimize it slightly. So there, everything you do, there is not a single hit hammer that will make your app like 5 times faster, like make your app 5 times faster. We could write a clickbait article on that. So everything you do will only be incremental like benefits, right? So this is one step. The second step, the red inter-service communication. Again, this is something specific to microservices architecture, but yeah, you will always have to have inter-service communication. And again, this is kind of a solved issue, right? We don't use Rust anymore, but it is like in the mainstream. Rest.
Okay.
We should not use Rust anymore. See the demo, but yeah.
We'll reclaim our
Please.
Just kidding. I'm trying to learn Rust.
ഇത് ദേഹത്തിന്റെ റോസ്റ്റ് ആയ പോലെയാവും.
So the initial idea was to use REST between for inter-service communication. Obviously, for browsers, we'll always with the clients we'll always be using REST. There are ways to use other protocols from the browser, but native support is only for REST. So, but we don't have to use REST here, right? We are not going to be having browsers as clients here. It is our services talking with our services. We could use anything. So the most common thing you go for is gRPC. gRPC is not the only thing here, but gRPC is one thing that is one go-to solution. So why gRPC? So actually this graph doesn't say a whole lot. You can make HTTP faster. You could use HTTP 2.1.
Wait, gRPC is built on HTTP.
Yeah, HTTP 2, right? So by default, when you are using HTTP normal REST, it will be using HTTP 1. So so gRPC, what it does to make it faster is not just faster, it has a lot of other things. One, the protobuf schema, right? It has a schema. When you are using Rust, there is no schema enforced at either end, right? By default. So, but while you are going with something like gRPC, there is a schema enforced. The messages are actually binary encoded, so there is a lot of optimization with data size. You don't have to send the entire schema all the time. The schema is known between the client and the server, right? They don't have to send the schema, they just have to send the encoded data, which will be a lot more compressed than just sending JSON string bodies, right? And another thing is, so again, if you have experience writing Spring Boot, there is something Spring Boot microservices. I don't know if anyone does have that. Yeah. So you will know Fein client, right? You will write basically a stub of whatever method or function you would like to invoke in the other service here. So you will just call that function as a function, but internally it will be issuing that request to the other service. But with going with gRPC, it will also do some amount of code generation. So it will generate the server and it will generate a client stub for you. So all you have to do is write the protobuf, let a tool like ProtoC generate that server and client, and just import it, call it. It's easily done. The only thing you have to do is write code is 3 lines. In Go, it is like 3 or 4 lines to generate that, to get that connection, and that too only on the client side, right? So we could go for that. Then another thing, so obviously we could look at how much request each framework is able to process in a second. But that benchmark actually in real life is not that very useful. You will not be hitting that limit. Most of you won't be hitting. So those benchmarks will be done for a simple endpoint that does not do anything. So it's just maybe a hello endpoint. You'll be looking at how much request that particular framework or language can handle. Most of the time, your latency, your processing time will be coming from database queries, and you could spend a whole day looking at database, how to handle that. So why are you using an ORM? That is so bad. Why don't you write your own SQL like people do? Like there are a lot of discussions about that. So one thing that is going to be like the main part of database, it's the time that is going to be time and resources that is going to be used is for getting the connection and closing the connection each time. So it's not like each time you will have pools. So I hope most of you are aware with what a connection pool is. So in your service, so if I'm user service, I'll maintain some amount of connections all the time. We'll call it as idle minimum or idle connections. So I will always have that number of connections like held. So if there are more connections required than that, what, so we will also set a max limit. So till then the services will be able to dynamically control how much connection it holds. So for Go, we could use something called PGX pool to do that. That is like already like standard practice in the within a service, right? We already do connection pooling. But what about connection pooling at the service layer itself between services? So here we use a tool called PG Bouncer. PG Bouncer that is specific to Postgres. So you could find similar tools like that, similar tools like that for other databases that you use. So what PG Bouncer does is do this connection pooling, but on a multi-service layer itself. So it will maintain
PG, right? Nginx for PG.
Somewhat. So what it does is it will have its own kind of ideal connection pool. Then we can set how much like maximum connections it can make. Then how much connections can be allocated to a certain service. So this service maybe we will only allocate maximum 10 connections. For the other service we'll maybe allocate it can have maximum 20-25 connections. And it's not just one-to-one relationship. So PG Bouncer can actually use a single connection to the DB to handle multiple connections with the service. So it does have optimizations on that level. So you might be, so if you are looking at the from service to PG Bouncer, you might be creating 20 connections, but PG Bouncer might only be actively holding 4 connections or 5 connections with the actual database. So and that resource of the open connection is need not be held at the service. That will be handled by a tool like PG Bouncer. So that is a way for you to speed up that part. So obviously still depending on how you write your queries, how efficient your queries are, it will still be a hit or miss. So that all depends. So again, incremental improvements. We are looking at incremental improvements everywhere. So now so I've already crossed 20 minutes. So
That's
yeah,
fine.
It's fine.
I'll try to. So one thing that is main. So you can write your web servers in C, everything in C. Write the most efficient SQL ever imagined. But if you have a bad front end to deal with that, it is going to be bad. The experience for the user is what matters at the end of the day. And this is where actually people should mostly be focused on than trying to get that incremental improvements in the UI. So if you have a desired page, a list of users, right? So the normal way, like magician Mudugat, appear from nothing, blank screen to entire table, everything is ready. This is the normal way. So still, yeah, still people will do this by screen to sudden data, and the
Loading.
thing everyone is familiar with. The merry-go-round, the spinner. It will keep on spinning. Spin some more. And then, ta-da, you have data. So again, this is the most common, I think. Right? This is the most common that we see. And it is quite easily done. If you have something like tan stack query, it will give us ease pending or ease loading. We could just use ease loading, then return spinner. Then when ease loading is over, it will go and print data. It is easily as done as that. So people usually go with this, right? But what actually should be done? So these are skeletons. We call them skeletons, but these are the non-spooky variant. So you will you will be showing some skeleton of what data would be there once it's loaded. Then you will fill that field, so it won't jump around. I think iOS, right? Their developer guide actually says not to use spinners. That is the only place, one of the few places that I've seen like actively recommend against spinners. Go for skeletons, but still it is like kind of rare to find. We do find it, but where we do find it, it is not implemented effectively. And there is one more solution, but that is not usable everywhere. That is show cache, then update with whatever it is from the database. So imagine you are building a notes app that has cloud connectivity. You wrote 5 notes from your phone, closed the app, went to your desktop, wrote maybe 2 more, or deleted 1 note, or deleted a user. We were talking about users, right? So when you open the phone back on the app back on the phone, it will show whatever data it knew before first. So it won't go to a spinner first. It will trust that cache data, then delete. So here we have the last user being deleted. Stand up. I think we all hate stand up. Actually, not that much, but still. So initially it will trust the cache. Then once it gets the latest data, it will go to that. Then the last thing is optimistic rendering. So again, you will be same UI. You are adding a user to it. You have an add button. You are adding a user to it, and so you press add. You get a sidebar or a model asking you to add a user, but there's something wrong with it. Yeah, if you are building forms, please don't. I hate this first name last name thing. Please don't do that. Just ask for a name, right? So so this is not in reference to any Anna not present here. So
where do you get these names?
Right, okay.
Okay. So you will be submitting the form, and it will be doing a post request to /users server. But you already have whatever data. It might not be the case every time. Sometimes you will need to populate it with data that is generated on the fly, like a user ID, right? But what you can do is add it to the list before you get the response from the server, right? That is why we are calling it as optimistic rendering. We are optimistic that that request would succeed, right? Then you will get a status, okay, successfully added user, everything is fine and dandy, right? But if it does become an error, right, bad request, then show a good toast, silently remove that, fade that into non-existence, right? That is not a like bad user experience to have. It is going to happen in very rare cases that an actual failure would happen. We know what is the failure rate for a simple endpoint, right? So that is a very rare case, and so we will know that only that very small amount of users are going to experience this UI change, that hiding of that row after it came, right? Even then, it is not as bad. We are showing the toast, could not add the user, and we are slowly fading it away. Again, try to fade it away, then just vanishing it. But yeah, so I had planned for a lot of other things prior to doing this, but then I thought, okay, time is going to be hard. That's why I ran through. I hope everyone got the gist of it. Right. Yeah. So that's it from me. If you do have anything to ask, you could.
About the gRPC thing, so do you actively keep a connection between the services, or is it like on request you make a new connection?
On request.
On request. Isn't that expensive, or can you keep like a live connection?
You could.
Yeah, I believe.
So gRPC is basically streamed.
Yeah.
You could have long-running sessions wherein long-running connections wherein two processes are forever in connection and forever speaking.
So there are multiple options to it. You could go for a unary connection where you just hit a endpoint, you don't get anything back. There are, as he said, streaming options. So it is customizable. We could do it however we want it.
PG bouncer.
Yeah.
In case of PG bouncer, so okay, show the diagram. So let's say we have to access something from the order SVC PG.
Yeah.
So like you had showed other diagram which says it had to bounce back within each other.
Yeah.
So like will that be able to be minimized? As in so let's say order SVC has to get something.
Yeah.
That only inventory has access to. So instead of requesting an inventory to access it, could it be directly accessed?
We could, but we don't. In microservices, you don't touch the data that the other service will own.
Then
Right.
it would have to hold like cache.
Or-
PG bouncer.
or,
That's too much context.
Yeah, that caching will be done on the service layer. So a service will might query inventory service. So it might keep a cache for that query. So it had asked what is the number of items for this item. What is the number of stock you have for this item. Order service might have asked inventory service. So if another query again comes to order service which requires that data, order service will have some type of caching to do that. So we won't be hitting the data in the DB that another service owns. That is always a bad idea. Yeah.
If you continue.
Yeah.
Yes, one thing. So when you do this from the front end side, and if it is for microservices,
Yeah.
do you make 4 requests to the thing, or do you make it a single request to one endpoint, and that endpoint calls the 4 services?
Yeah, we will only have one endpoint, and so you will be running it at different ports at different locations maybe. So you will have an API gateway.
Right.
So API gateway will make sure that all front-end requests will come into one URL, one port, right? And that will do the traffic routing to whichever service. So you will be hitting just one service, but the front end will at a time. So if you the front end goes, so you try to load up the catalog, it will hit the catalog service, or and catalog service is responsible for hitting recommendation service or whatever. If you go to the order screen, it must show the orders. So the front end will only try to hit the order service, but that will be doing whatever things other than that. So front end won't be handling that inter-service communication, and it will get all that whatever data is required for the front end from the other services, that service's responsibility. It is that service's responsibility, and it will give the response with whatever the front end needs.
I'm assuming that if it goes to /products, it will go to this particular service. Like
Not necessarily. So you could have. So that is just a UI. So you will go to product screen, right? But that might not always.
I mean saying that when
WordPress mapping.
wouldn't like one endpoint.
Yeah.
One endpoint.
Oh, okay. Like
accessing
in
all-
the API endpoint. Yeah,
Right, right.
yeah. We'll usually map. So by default, if you're again talking about Spring Boot, it has a the default like kind of API gateway / load balancer we use is something called Eureka. That is actually built by Netflix. Lots of things in microservices are built by Netflix. They kind of pioneered the idea. So in Eureka, the default mapping will be your API URL / whatever service name you have, then thing. So that is usually what we follow. So order service would be your API URL / order / v1, then whatever. For user service, it might be your API URL / user / v1 v2 something.
And is Java going all microservices currently? What's the situation right now? Is it that way?
So Java,
It's a language.
It's a
Like,
yeah,
you
it's-
can implement anything with Java.
No, I'm saying the ecosystem is moving that way. Particularly Java. Is that a scenario?
again, that comes to the debate of should we move everything into microservices.
Right. Rails people don't, so that's why
Yeah,
I'm asking.
so Rails, the main idea is the monolith. It is
yeah.
designed around the or no, maybe you could make microservices.
Yeah,
You could
What-
make microservices
what
and
is the
everything.
what is the difference between microservice and here? Like, what are you talking about?
I'm showing the ecosystem is moving
So,
towards that
so
kind
his
of
question was like, is the Java backend system mostly leaning towards microservices
You can build
architecture?
both.
Like,
You can
yeah,
build both.
no, as in the community,
Yeah, right,
whatever
right,
is
yeah.
the current trend right now.
Yeah.
It's all a
Uh,
trend.
So with Java, like even the smallest niche architecture that you are being looking at will be huge, right? The number of users still using Java is like a big number still. So microservices is one thing, especially in the field that we work on. Microservices are kind of the way to go. That is particular to our field or whatever clients that we have, right? That style of platforms. But no, there are still monoliths, large monoliths built using Spring Boot.
It all depends on the use case.
Yeah.
Yeah.
Yeah. Anything else?
Can we use different databases for different services?
Yeah, of course. You will be using different databases. Sometimes, for example, you have a certain service that deals with unstructured data. You might be hitting MongoDB or you might be using Firebase. Yeah, that could also be done. You could do anything. That is
No, like, then how do you do PG bounds? So you have to do multiple PG bounds instances separate from each other.
so that makes it so you will be looking at if you have so you won't be using traditionally you might have different types of database, non-relational databases, but if you are going to stick with relational databases for multiple services, you will go with just PG or just MySQL. You won't find one service using
It depends.
Postgres.
It
Yeah.
depends. So,
Yeah.
like, I am telling from my own experience, we have, like, we have row-based data for user holding user data, and for holding less frequently updated data. But at the same time, we also use columnar database for storing real-time data.
Yeah.
We have like data that's coming in at the rate of 1 billion rows per second sometimes. So for that reason, columnar data is better.
Yeah, I meant in the
And
case of using a certain. So if you are looking at a certain use case, right? If you are having PG as your database for storing what all structured data is there, unless there are certain specific requirements where you need unstructured data or you need very high
Real-time
number
data.
of writes, you will be sticking to PG itself over all of the services you have.
So it's like all you have to make choices.
Yeah,
You have to
that
make
is
them
decide.
based on
So these decisions have to be made before you start.
implementing.
Yeah, otherwise you could do that. That is what actually happens most of the time, to be honest. But it is going to be a hard thing to do.
Hard thing to solve.
Yeah.
Debug.
Let's take a break. Hey Dave, let's take a break.
Yeah.
Yeah.
Thank you.
Alright, thank
Yeah.
you.
So the snacks will be available this side. Yeah, outside this door. Don't take it personal. Don't take it personal here.
I have to reclaim our
I was
full red spotlight.
Basically trying to keep myself updated. ഒരേ സൈറ്റിൽ ഡാമേജ് ആയി പോകാം. I want to work with real time data. നമുക്ക് അത്ര real time data ഇല്ല. Since we are just having like high frequency.
So am I audible for everybody?
Yes.
Yes, right. Okay. So yeah, just now we had one session where IT was talking about microservices. Now let's talk about micro frontend. So we talked about a bit of backend. Now let's start exploring to the front end side of things. Okay. So who am I? So I am Rahul Menon. I had the UI UX practice here in Litmus 7. And if I talk about my team, it's around 80 plus team members, predominantly who are UX, UI, UX engineers. So now, if I talk about this today's agenda, what we're going to do is we will talk why do we need to have micro frontend. So we need to understand, like, when we talk about micro frontend, what does it bring to the table? Why do we really need it? And from there, we'll start exploring what is a micro frontend and what are the principles we should be using in order to have the micro frontend implemented. And then we'll start talking about, okay, we know about micro frontend. We started exploring micro frontend. How can we implement it? Now, talking about micro frontend. So, to understand micro frontend, as Aitya talked about, let's understand the journey. So, initially, when we were in this monolithic world, so we had a simple monolithic application which is interacting with a database, and it is being supported by a single page application. So, I'll be talking about all these concepts quickly, just to make sure that okay, within the 15 minutes, I'm able to talk as much as possible. And if you have any questions, please feel to stop me, ask me questions, and we'll talk about it. So yes, so coming back, we have a monolithic application, we have a database, we have interactions happening there. So this was good, but is it scalable? Not necessarily. Is it modularized? And is it providing the necessary independence for our team to make sure that okay, yeah, these applications are able to grow to such extent? That's where we started going to the world of microservices, which IK talked about. And so there, we have a single page application interacting with an API gateway. And then we have a list of microservices, which is again having a domain-driven architecture, where we'll be specifically focusing on specific domains, subdomains, and there it will be interacting with its own business logic. And based on that, the single page will be rendering all this application. But now, this is all good from a backend perspective. So now it's modular, scalable, and even in terms of technology. So we are talking about Rust, Go, Java. A lot of technology flexibility is actually available when we are moving away from the monolithic application to the microservice implementation. And in terms of team autonomy, now you can have independent teams work on independent modules without knowing about the entire application. There can be business logics built, there can be features be built without really worrying about what the other teams are doing. But there should be an understanding, but it's not going to prevent us from a development perspective or from a feature enhancement perspective. So having said that, now let's come to the front end. So yeah, let's say I have the microservices implemented as I just said. But now think about the front end side of it. I'm still lying in the monolithic world, where my team, when it is a single team, it's very easy for us. But think about, let's say more than 5 or 6 teams working on the same code base, and this is one of the places where I really wanted to talk about. So when we were interacting with clients, as soon as I came into Litmus 7, we were interacting with clients where clients were bringing this huge concern that they are on this monolithic architecture, they have this big application which is e-commerce focused, and they are not able to scale it up to the desired limit. They are not able to push features in the desired way they wanted to do it. So what can be the solution out of it? We did not have an immediate answer, because whenever you're going for front end which is built on micro frontends, you need to understand what is going to be a design strategy and what does it address. So the second problem which we are facing from a front-end perspective is always about communication overhead. Is it only restricted to monolithic? No. It's also going to be the same case if you're not given precautions when it comes to the backend or the micro front-end side of it. So there can be micro communication overhead when you're interacting with modules, when you're interacting with feature teams. And that was really challenging for us because they were now, if you look at the backend side of things, they were completely business domain focused, and we are not having clear clarity in terms of what is happening where. And when you're thinking about more than 10 teams or let's say 100 people working in tandem, this was really hard. And even if you look at the backend side of things, things have become autonomous. But front end is still in the world where they are not come into the micro front end world. They're still stuck with huge code base, going to a huge code base, and they are really scared to make minor changes. So, having talked about the challenges, we started thinking, how can we really change it? So that's when we started understanding, okay, let's explore this microfront concept, which has similar principles to what Aitya talked about from a microservice perspective, and it also brings in a lot of advantages. So what you see here is, now all this micro front ends is interacting to the API gateway, but here in the front end world, we are starting to move towards the domain driven architecture side of concepts. And there, each front end team will be autonomous, and that's a big advantage. So here, I will be having my team working on only specific area. For example, let's say the home page. In any e-commerce site, you'll be having a home page. Now, my homepage team will not be focused in terms of what the business logic the PDP or the PLP page is going to do. So that autonomous behavior helps us to do parallel development. It helps us to make sure that there's a good amount of ownership. We can start developing applications and also deploying applications at a faster rate individually. Now talking about responsibility. So when you're in a monolithic application, people are scared, and in terms of responsibility also that's the case. So here, if you look at it, responsibility is no longer going to be spread across. Here, I'm going to have a focused approach where my team will be looking at a specific domain, specific business-centric approach, where I'll be working on a specific domain, and I'll be having complete ownership about what I'm going to do. Now think about a monolithic application. Let's say front end is ever evolving. Now what you see today might be changing tomorrow. There was a time when we were only dealing with JavaScript. Then started coming frameworks like Angular, Vue, React. Now there are new frameworks as well. If you have heard about it, there is a framework called Astro, which talks about island architecture, which is a totally different one. And there are also new Solid.js. All those frameworks are coming into action. Now let's say I need to innovate. I need to understand where my specific feature or my specific domain can benefit out of it. So innovation can happen in parts, and then it can be leveraged to a platform level. Let's say I did it for a specific micro front end. Now I can take the same thing, have it implemented across all the micro front ends. Now that gives me a lot of flexibility, a lot of scope for gradual improvement, as again Aitya talked about it. So now I talked about why do I need it. Now let's understand what is the definition of micro front end. And if you can see, I've also highlighted few specific areas because this is the heart and soul of micro front ends. So if you go to this microfrontends.org, this definition is something you can easily find. So the idea behind micro front end is all about thinking a website as a composition of features. So let's say if I have a header, I have the content side and the footer. All this will be composition of features, and we'll be splitting it up. And then we'll be starting to deliver it with independent teams. So the ownership is to a specific team to define a specific feature or a business. So that's where we say each team has a distinct area of business where it cares about, and it kind of specializes it. So this is really helpful for us. But this comes with a lot of caution because we need to know what we are doing and how we are doing it. So the team is also expected to be cross-functional and should be able to understand the overall picture of it. So when I talk about it, the end-to-end from the database level to the user interface level, we act in pods. We are domain focused. So I'll be interacting with the microservice or the backend person who is going to understand that well and start helping me achieve it. So this also gives you a flexibility as well as a better interactivity when it comes to how we are going to interact with large projects. Now, what are the core principles? So, this entire micro front end is built upon 5 core principles. One is when I say autonomous teams, it's all about being able to deploy front end applications independently. And then, as we talked about earlier, it's also about making sure that I have to have the cross expertise. And the next one is also making sure that, okay, when we talk about micro front ends, there should be a parallel development that is happening and a business centric approach where I will be isolating what I need into specific segments. Now, small and decoupled. So, what are be the logic I'm writing? It should be small, it should not be coupled, it should be loosely coupled, and there should be a contract which I set with the API layer or with the other micro front end, which can really help me achieve what I need. So, there are 3 more principles which is always talked about when we talk about being small and decoupled. It's all about easy to use, easy to understand, and easy to modify. Now, micro front ends, the heart and soul of it is all about having a business domain centric approach. So, what I mean by that is, it is going to be focused on a specific domain or a subdomain when I'm building micro front ends. So, you need to see the smaller part of the picture and also the whole part of the picture when you're building an architecture around micro front ends. And this needs specialized team who can start focusing on individual bits and then start elevating it to the entire application, start understanding where the communications are going to be, how the communications are going to be. Now, removing boilerplates. So, micro front end depends heavily on removing the boilerplates. So, when I say removing boilerplates, it's all about making sure that there is standardized documentation, code, or the best principles are outlined clearly for every team to follow. Because when I'm going the micro front end route, communication is key. And for efficient communication between large team or the production ready application, it's all about making sure that we have documentations, we have best practices that is being defined at a project level. Now, the other or the last point is so that, okay, when I'm coming with micro front ends, the UX is always being consistent. It cannot be that, okay, I have one page which is following a specific design system, and I have my other side which is following a completely different design system. And that's again something which Aditya talked about. But there, we need to know how we are going to define the design system, how do you work with the design system, and how do you make sure that all the micro front ends, which is going to be part of the root container, is going to follow this consistent UI UX. So yeah, that's about what are micro front ends. So we talked about why do we need it, what is micro front end. Now let's talk about how to implement this micro front end. So I've just divided this into let's say 4 different segments. One is the integration. So when you talk about micro front end, there are 2 ways in which you can start bringing in micro front end. One is the build time integration, and that's something we might have. If there's any front end engineers over here, we might have definitely used it. You remember the NPM packages? That's the build time integration we are using, where you will have NPM packages built into your packet.json, and there you will be using it as part of your project. But the problem there is there's a lot of code duplicity, there's a lot of code bloating that is happening, and that is the reason why this is not the best or the suggested way of going with the integration that is suggested. Then we also have a runtime integration, where let's say when I'm talking about runtime integration, all this micro front end interaction, or let's say when I have a container and I have a set of micro front end, what happens when I interact with one micro front end to the other micro front end? How does that interaction happen, or how does the integration happen? That is decided by runtime integration, and we'll be talking much more detail. And this is also governed by the composition, where we can have it server side, where my nginx server or my Apache server will be telling me, okay, when the URL is being hit or the micro front end that is need to be delivered will be handled by the server, and that will be corresponding micro front end will be loaded to the front end. Then we have CDNs, which is used for the edge side composition. And when we talk about client side, we have frameworks. We might have used iframes as well. So we have iframes, we have web components, we also have a new technology known as open components, which all supports this client side components. So yeah, even in terms of approaches, so it's also when we talk about composition, everything is done with an approach. So you can see that, okay, we might have worked with iframe, but we necessarily do not know that we are working with micro front ends here. So then there is a new concept called as open components, where the entire business logic for, let's say, the header, the open components holds the business logic for it, the interactivity for it, and those are being shipped as an open source element where you can start interacting with your open source component and make sure that the things works well. Then there are stitching frameworks like single spa, module federation, and web components. So this has its own benefits, its own discriminates. We'll talk much in detail about it as we go forward. Now, the last important piece is communication. So when you talk about micro frontend, understand this, okay? All these micro frontends are individual segments. So how do you interact with it? So one of the efficient way of interacting with this is making sure that we have shared state management. So when I talk about shared state management, it is all about using props in the React world, or let's say we have the Redux, or we have the global state management. All those can be used as part of the communication. Now the platform specific API. So we have local storage, we have also the async emitters in terms of mobile, which can be used as the platform storage APIs, which can be used for communication when we are building microfrontends. Then there is event-driven architecture. So when I talk about event-driven architecture, it's all about, let's say I have the platform is going to give me certain events, and those event emitters, let's say when I'm talking about a browser. So the only problem for this specific architecture is this cannot be used in terms of mobile, but this can be used when you talk about the web development. The good thing is you will have web or the Chrome emitters which can be used, or Chrome specific events, and that will be used to interact between the different components or the different layers of microfrontends. Then there is also a push, like we can have our own custom message bus. Like we can have a PubSub mechanism being implemented where it will receive notification, it will hold the data, and that data can be transmitted to end microfrontends and have the communication being established. So what you see here is the build time integration, where let's say we have 3 teams who will start creating this npm repositories, and this will be integrated with the integration team, that is my team D, and that will be deployed to the web server. Now let's take a scenario where team 2 is making some changes and having that deployed to the package repository. The problem here you face is the integration team should be aware of it. So here a lot of communication, a lot of code duplication may always happen, because let's say the team 2 made a change which the team 3 is not aware of. So what happens is there's a lot of code duplication, and all those code will be pushed to the npm without each team knowing what is happening between each other. And the integration team needs to make sure that there is an efficient communication to make sure that if there are changes in any of those teams, they need to be able to integrate it, build it, and deploy it, so that all those changes can be efficiently brought about as part of our microfrontend. Then we have runtime integration. So when you talk about runtime integration, we talked about it. So we have the server side as well as the client side. So here in runtime integration, what happens is when I'm hitting a browser, it at that particular moment will take the help of the server side or the client side composition. And in terms of the server side, what happens is I have my Nginx server or Varnish server interacting with different microfrontends, and that will be catered to the root container. So I will have a root container, I will have a microfrontend. My root container will start interacting to the Nginx server or the server that is going to be there in between all those microfrontends, and the required microfrontend will be passed across to the front end. Similarly, the client side, the only difference is in terms of rendering, it is much more efficient, and there is a lot of advantage when you're working with client side rendering here. So the composition happens inside the browser. So the loading, the preloading, all those mechanisms happens inside the browser, and it is much more faster. So here we use frameworks like single spa, module federation, and those frameworks, what it does is it makes sure that this routing navigation is really efficient, and it can be preloaded, loaded more fast compared to the server side or any other composition which we have. Now, just wanted to talk about 2 most common frameworks which we use as part of microfrontend. So what we have used so far is single spa, and we are slowly starting to move to the module federation side of it. So single spa is nothing but a JavaScript library which allows for the creation of microfrontend in a single application. So what I mean by that is it has a root config, it has a microfrontend application, and these 2 configurations will be tied together with the help of Webpack. So a shell application that will be loading it and managing all the micro frontend and the navigation as part of the micro frontends. So here, the only problem is it gives you a lot of flexibility. When you talk about single spa, I can use Vue, React within the same module. But when it comes to module federation, that is not true. Where if I'm going for a particular module, that module needs to be on a single particular framework. And module federation is much more famous because of the community support, the interactions. But in terms of documentation, we have to be make sure that okay, from a technology side, we need to be aspirant. And when you're moving towards the micro frontend, any application you're going to build, you need to make sure that you're technology agnostic and you're able to understand all those concepts very clearly. Because in terms of the production world, you're going to face a lot of challenges. And as part of our journey, these are the learnings which we had. So the one of the most important learning when you go to the microlithic architecture is you need to have a very strong foundation. It is all about creating a single page application illusion, but scaling the teams, making sure that all team understand what their responsibility clearly and they are able to create autonomous code. It's being said, it's very easy, but bringing it into action is really, really tough. Now the next is how can we use a different set of frameworks? Does React work well with Webpack module federation? Does it work well, even better with single sparse? This kind of experimentation and evaluation needs to be done from both perspective before we go and start working with different frameworks. So that is going to be very important. Then is the deployment strategy. So let's say I'm having one application and deployment is tough for me in a production environment. There, it doesn't make sense to go for micro frontend because right now I was having issues with deploying one application. Now you're looking at deploying an application, and that is going to make your world even more tougher. And make sure that you have a root container or a shell where it is going to be the single entry point for your application. And that is very critical for us because if you're having multiple entry points, it becomes very cumbersome to make sure that okay, you have a clear definition of what your micro frontend is going to act upon. So the next is understanding and acting on feedback. So let's say we have performance improvements to be made. You need to work on specific areas. All those feedbacks needs to be collected, and that needs to be moved to the innovation side of things and start working on those innovative things and slowly start bringing into the platform level. So when you talk about developer experience, it is also about making sure that okay, if I'm bringing in a micro frontend, it should not be orphaned. It should always be optimal, and it should be having a specific domain in focus. And also, the most important aspect of it is understanding the infrastructure. So when you're building a micro frontend as a developer, I would just like to explore it, but think about the bigger picture. When you're working on a project, there is always going to be a cost of infrastructure that is going to be tied in. How does it work, and how can that be optimized is also something you need to clearly understand. And innovating is very critical. So let's say recently there was a Webpack 5 that is being introduced. So let's say if I need to bring those kind of specific improvement updates to a production ready application, we can start building that at a micro frontend level and then slowly start applying it to all the micro frontends. But that's a process which needs to be documented, and that should be clearly communicated to all levels. So last but not least, now whatever you talk about in the front-end world is all about performance. So when you're introducing this micro frontends, we need to be making sure that we have monitoring aspects clearly defined, and overall the application is going to be performant. Any questions? So that's nearly it. And I know I ran for this 15 minutes. Any questions on the side?
Is this a fairly new concept, or like do we have websites or like applications that are using micro frontends right now in production?
Yes, we have.
Is there any examples?
Yeah, so if you talk about Uber, you can talk about Walmart. You have also Netflix implementing it. You have Facebook implementing it. This is actually a concept that is widely used. Let's say from the front-end side of things, this is being in implementation for the last more than 5 years. But it's still evolving.
Can you explain a bit about shared state management?
Yeah. So when I talk about shared state management, it is actually in 3 parts. So let's say if I need to interact with 2 micro frontends, I can use that. I can do that using Redux. I can have a Redux layer which can interact with this micro frontend and also with my root container. Root container will orchestrate that interaction but all will be happening through the Redux layer. Even I can have a context API being defined for the shared state management. It can be stored in local storage as well as cookies, but it can also be, when you talk about mobile, there can be an async mode as well to have this.
Every developer in the team has to be sync about the variable and rest of the things.
Yes. So when you're talking about the development for micro frontend, every team should start interacting regularly with all the other teams to understand the bigger picture, because we might be developing something which is similar in nature for all the like for similar micro frontend. So we need to be understanding where the interaction needs to come, how the data management needs to be applied.
Okay, so in single file you mentioned that we can make a React and Vue work together in some way. So how does the routing work?
So that depends upon how you define your import maps. So when you talk about navigation or routing, in single file it is done using import maps. So there what you can do is, when you talk about the import maps, right, you can define the import maps for the Vue application or the React application, which will start catering for its need.
Okay, uh, the bundle size will be large, right? We have to like download the entire React as well as the Vue and all the dependencies they have.
Yes, and that's one thing we need to be careful. Do you really need to have Vue? That's the first question you need to ask before going there. Because if I'm bringing in the island access, or if let's say I'm bringing Astro, it has its own advantages and demerits. What is the cost of bringing such a framework? Because every framework will bring a huge amount of code as part of its integration, and that is definitely going to be there. But let's say if I'm going to reuse it for n places, then there's an advantage there, because the framework code is minimal, but the advantage where when you share it is going to be really, really huge, where it starts plugging into the performance side of it.
Okay, so if two frameworks are involved, can we use them in the same screen or does it have to be in different browsers?
No, we can use multiple frameworks in the same screen. That's the advantage of single spark. But when you talk about module federation, that is not the case. You can have one module specifically to one framework. But let's say if I'm having different modules, then I can have one module in Vue, I can have one module in React. That's the way it works.
Okay, so these are in multiple code bases, right? So
Yes.
are they integrated into a single code base before deployment?
We can do that. So that we can also have monorepos. We can have monorepos, which is actually going to improve the overall efficiency of how we work. But that's a like choice in terms of how do we want to share the code. Do we really want to share the code? Because what you've seen in production ready application is, there is certain places where they're not ready to do it. Certain applications are really secure, and there monorepos doesn't help us.
Okay, in terms of like microservices, let's say we are having containers, we have like Docker Compose or like Kubernetes to, have separate microservices. Like from my understanding, single SPA is something that facilitates, multiple, what you say, components for the front end. Like, is that the,
Yes.
is that?
Yeah, so basically what happens is, there will be one container. When you talk about single file, it will have one application shell. And then there will be independent micro frontend, which is going to be independent applications. And this will be all stitched together using the import maps.
So, single SPA is the one that facilitates all these.
Yes, single file is the framework which stitches everything together. In terms of React Native project, we don't explore that one, because when you talk about React Native project, it's not really that huge. Even in terms of e-commerce, it is just taking speed there. Okay, so having micro frontend there is going to be really tough for you, because when you're talking about mobile application, it is going to be more focused development there. So having a micro frontend approach right now doesn't seem like the right choice for us.
So let's say I need to update from Webpack 4 to Webpack 5. So right now it is slightly difficult right now because the micro frontend architecture demands us to update everything together, make every team work together, and then update it. So isn't it making it difficult for migrating to a later?
Necessarily not, because what happened is, let me give you an example. Let's say while we were doing the same upgrade, say we had single SPA application which was on Webpack 4, and we were trying to change it to Webpack 5. Okay, so what we did is, we focused on a small segment. We started experimenting on footer along with the root application. So root application is something we cannot leave without. So we started with root application and started doing the hydration from the footer component which is going to be supported by Webpack 5. Okay, so that is going to be very easy. Once that is done, it is also being supported by the single SPA itself. So that can be done. But when you talk about single SPA, now with the latest update, it's slightly supporting the client side. It's not even thinking through the server side. So Webpack 5 works with the client side rendering, but not efficiently with server side. So what we have to do is, we have to be tech savvy there, where we need to go through their code base, understand it, because right now what is happening is, single SPA in its core framework itself, to support the Webpack 5 upgrade, is itself client side. So we need to patch and make the necessary changes to make sure that it is working in the server side. But whereas in module federation, since it is closely tied with Webpack, that communication on server side interaction is much easier.
Alright, we'll do the next talk. Okay, thank you.
Thank you.
സ്വിഫ്റ്റ് എന്ന് പറഞ്ഞൊരു ആൾക്കാർ യൂസ് ചെയ്യുന്നത്
Give it one shot, crash आया, let it go. You Chrome, you put Chrome here. Chrome update है. No man, island അല്ലേ?
Oh,
it's fine.
പ്രകാശ് അല്ലെങ്കിൽ എന്താ ടൂറിസ്റ്റ് സസ്പെൻഷൻ
ബ്രൗസർ എടുത്താൽ എന്ത് സീനാണോ
അതിനും പാസ്വേഡ്
ഞാൻ ഒരു സാധനം പയ്യൻ
Susan's comments.
എന്തൊക്കെയൊക്കെയാ ചെയ്തൊക്കെയാണ് പോകണം റോഡ് വന്നാലും പക്ഷേ റോഡ് അനുസരിച്ച് 600
I think it's more like a problem with I think it's better with Chromium.
അല്ലെങ്കിൽ ഡബിൾ റേറ്റ് ആവും
ഇങ്ങനെയാണോ
Because I use Chromium with
ഫാസ്റ്റ് ആകും എൻ്റെ കാശ് ഡബിൾ കാശായിട്ട്
ഞാൻ രണ്ട് ഉദ്ദേശം ODT ഫയല് കിട്ടുകയാണ് ODT ഫയലിനകത്ത് ടെക്സ്റ്റ് ആസ്ക് ചെയ്താതിരിക്കട്ടെ അതിൻ്റെ ഫോർമാറ്റിംഗ് കളയാതെ ഓരോ ടെക്സ്റ്റിൻ്റെ ഇത് മാത്രം മാറ്റി കൺവേർഷൻ നടത്തുക ബേസിക്കലി അപ്പോൾ ഞാൻ ലൈറ്റ് അപ്രോഷൻ അത് ODT ഫയൽ കൊടുത്താൽ ഇംഗ്ലീഷ് ലാംഗ്വേജ് ട്രാൻസ്ലേറ്റ് ചെയ്ത് തരും ODT ഔട്ട്പുട്ട് കിട്ടും ഇവിടെ ഒരു സി ലൈബ്രറി ഉപയോഗിക്കുന്നത് സി ഫിൽറ്റർ ചെയ്ത് തരും
വളർന്നു ലാസ് വെഗാസിൽ മറ്റേ ബട്ടർഫ്ലൈ പോലെ സാധനം ബട്ടർഫ്ലൈ ഇങ്ങനെ കുറേ
Are you getting it or no?
ഇത് എടപ്പള്ളി ഈ സൈഡിലാണ് ആലുവ സൈഡിലോട്ടില്ല എന്താ എടപ്പള്ളിന്ന് ഗുരുവായൂർ പോണ ആ റൂട്ടിലാണ് റോഡ്
Yeah, do that. You can start anytime.
മറ്റേ കടൽ 5 കിലോമീറ്റർ അതിനെക്കാട്ടുണ്ട്
സുബിന് നേടിന്റെ ഡെഫിനിഷൻ
മറ്റേ മുംബൈയിലെ 5 കിലോമീറ്റർ അല്ലേ കടലിന് പോയിട്ട്
അതെ അതെ നമ്മൾ സ്വയം വിശേഷിപ്പിക്കുന്നത് അങ്ങനെയാണ്
ബൈക്ക് ലൗഡാണ് പക്ഷേ ഇതിൽ
സിസ്റ്റം സെറ്റിംഗ്സ് ഡിസ്പ്ലേ
ബാക്കി റോഡ് ലെവലുള്ള റോഡിൽ
ലെവലുള്ള റോഡുണ്ട്
മിക്കതും ലെവലുള്ള റോഡാണ് ബ്രിഡ്ജിൽ മാത്രം കയറ്റാൻ പറ്റും
ആ ഓക്കെ സർ ബ്രിഡ്ജിൽ അലൗഡ് അല്ല മുംബൈയിലെ റോഡ്സിൽ അലൗഡ് ആണ് ground level road.
ഗ്രൗണ്ട് ലെവലിൽ ബ്രിഡ്ജിൽ മാത്രമല്ല ഫുള്ള് ബ്രിഡ്ജിൽ ക്ലെയിം ചെയ്ത ലാൻഡ് ഉണ്ടോ?
ഇല്ലാതും കേൾക്കാൻ പറ്റും. ബാക്കിൽ ഓഡിബിളാണ് പറയുന്നത്.
ഓഡിബിളാണെന്ന് എനിക്ക് തോന്നുന്നു. ഉപയോഗിച്ചോ?
Hi. Okay, first of all,
പുതിയ ഫ്ലൂ ഇറങ്ങിയിട്ടുണ്ട്.
Subin flu.
Okay, like it's really my pleasure to see all of you. Like it's like seeing a bunch of same-hearted nerds, all united under FOSS United. Yeah, it rhymes. Okay. Hi. Can you please give me a stretch or something? Like I'm a bit uncomfortable.
This is not your first talk or something, right?
Yes, it's my first time.
This is your first talk?
Yeah.
Oh, okay.
So please bear with me. Okay. Devsi, like I wanted to I today want to like be talk about my first project, like maybe my first big project or my first personal, maybe a big kind of thing. Hey, today I want to talk about Devsi. Like it's a automation tool I made in Go, and it is just for making the development of development using containers more easy for us guys. So let's start with the newbie talk. And on starting, like I'm Agus. You can find me online under Brutus. That's my like official username. And I'm a software enthusiast, force lover, and philanthropist, of course. And currently I'm working as a philanthropist. Yeah, the Tony Stark thing. And then currently I'm working as an R&D engineer under Fixed Dynamics. That's a startup where we will be working more into some AI related solutions for some fintech specific problems. And yeah, by the way, I use Archlex. I used to use Archlex, and I figured out I got a life life to live. So currently I am moved on from that thing. Anyway, the important thing is I only use Linux. Okay, fine. And it technically implies today we are only going to talk about Linux. Yeah, GNU Linux. Sorry guys. Sorry. Fine. GNU Linux. Probably it is more into Linux features, Linux kernel features. Yeah, still GNU Linux. Fine. Yeah. And if there are any Mac or like other Unix users, like you can probably resonate. But if you guys are using Windows, I'm really sorry for that. And that's all about me. And let's start to the story. And I was introduced in the field of containers like maybe 2 years ago. Like I was another like some physics nerd pursuing my BSc in physics, and I got a computer and I was starting to do some software things just to impress my ex-girlfriend. And the problem I have faced is that like I was using Linux. Of course, I break my Windows 10 system for an like update, and I started to use free softwares, and that was an old computer for sure. And the thing is, like I made a lot of cool stuff in Linux. Like Linux is made for that thing, you know, is. And the problem is, even if I done that thing, like I won't be able to deploy that my application into her application. That essentially my view and my aim is to impress her. You know? I don't know. That's my ex-girlfriend anyway. Okay. Okay. Got it. So I searched a lot how to simply package a thing and ship my application to another computer, and I came across the idea of Dockers, but I was doing the like some front end, maybe some desktop application. So Docker wasn't a
Very weird now.
Go ahead. Sorry. Like it's a new video. Fine. And yeah, and I entered this field and I see Docker and I skip it like it is not meant for me that time. And later I came into the current firm, and that is when I realized I really want to look into this field. Otherwise, I am not going to thrive on the company. And I started to do understand Linux. So I asked containers, what are you? And it was like containerization is an operating system level virtualization or application level virtualization over multiple network sources so that software applications can run in isolated user spaces called containers in any cloud or non-cloud environment regardless of type or vendor. Yeah, that's great. I mean, I see such a like great selection of words. I didn't understand anything, and after like a lot of months passed, like probably like a 60 months of efforts and exposure and some searching and research, I think I get into that stage of probably I understand containers a little bit, and probably we can go about the basic features of containers and the basics of containers I learned, I understood. Let me cover it, but in some maybe within some 3 minutes or something. Okay, the why and what of containers. Yeah, you guys seen this thing. Sorry. Fine. Yeah. See, you got this problem. Like, you got a virtual machine or you got a large server. It got a high end spec and all. And your problem is you go two clients as well. Like, you have to share your big server to two more clients. Say their name will be Shari and Mary. And okay, essentially you want to share it. Okay, the problem, like there's a problem, and before containers the common way to resolve this thing will be using virtual machines. And in the case of virtual machines, you'll be simply like split up your hardware using a like firmware called hypervisor, and you will be installing multiple OSs on top of the same system, and all of them will be running parallelly in the sense. And yeah,
Hypervisor is not. Hypervisor is like an
Yeah.
underlying layer.
yeah, it's
Like
the
it can be,
firmware.
yeah, it
a
can be
firmware.
directly metal, bare metal.
Okay.
An example would be VMware.
Oh, okay.
Yeah.
VMware has a hypervisor.
And I will eventually install the Shadi's application on the first container or the first virtual machine, and Mandy's application on the second virtual machine. Okay, that will be my way of deploying the things. Like it got a lot of issues, like you guys know. Like if I want to accommodate a new party into my scenario, like it is going to be a bit messy. Like I have to restart the thing, or I have to reallocate the whole like statically allocated space and all. So it is not dynamic. I get no like control at all. So you can otherwise go with the like forward approach. Like you can install a whole operating system on your system, and you can install the Shadi's application on the system. Also, you can install the application from the mail. Like, but it is not safe at all. Like it's the straightforward way we are going to do. Like, what if Shadi got a malware in it, or what if Shadi's application, or what if Shadi is a hacker?
Oh,
So-
Shari finds about Mary.
Yeah, that's also an issue. Like in that case, Shadi's application can definitely find support the Mary. That's also a point.
Good one.
And now, like we got the solution of containers. Like it was introduced in the 2013 by Docker. Yeah, Docker popularized the term containers. And the case of containers, like it like allows me to do this thing. Like I can install a whole operating system on top of my whole hardware, so I can handle my whole hardware using my operating system. I can do other stuff on it, and in addition to that thing, like the applications provided by Shari and Mary can be separately packaged and run above the like operating system I am hosting. Like it's more like sharing the same kernel, but all the other things. I mean, the application of Shari and Mary will be completely separated. Great. So, like, what is basically allows me? Okay, fine. What basically make me capable is something like I can run the both of these application, these containers application, completely separately, and they like all of the processes spawned inside these like containers will like it will be fake to believe that like they are running independently. So essentially Shadi and Mary will now think like they are occupying the whole system, but they are not. And I can dynamically allocate the space to each of these containers, and I can dynamically allocate the resource and other things to it. So
you can also totally gaslight both of them.
yeah, sure.
Now we know how is
Yeah.
And also I can accommodate a like maybe
Third
a
one.
third
Third
one
one, yeah.
in the runtime. That's the main advantage. So that's fully it works. It's great. And so basically containers made us these things like it made us capable of running dynamic cloud-based super scalable applications. Like yeah, literally that's it. It does. And it made us capable of easily handling deployment of tons of applications using some simple configuration files and all. I'm talking about Kubernetes and those kind of container like orchestrational tools. And yeah, the tons are a bit exaggerated. That's why. And mainly and most importantly, at least for this contest, they help us to package an application that works on our computers. So it essentially solved this problem of it worked on my machine kind of excuses. So that is where we are more into, like that is where I am more into. But how? Like how does containers do all of these things? Like let's get a bit deep into it. Yeah, it was but why, but I won, but how? Okay, fine.
The hemoglobin എന്ന് പറയുന്നത്.
Yeah, it was actually namespaces and C groups and CS root. Like
Jails.
CS root. What, sorry?
Have you heard of the concept of jails?
Yeah, exactly. I'm going into that.
Okay.
Anyway. And namespace, C group and CS root, like CS root will be pronounced as Chirut by me, like don't take it wrong. If you get yeah, yeah, that's my convention. Anyway, the namespaces, C groups and Chirut, like sorry, that's my phone.
ബീറിലിട്ട് ബീറിലിട്ട് come on let's go come on
Okay. Okay, the community member is forcing me.
ഞാൻ കമ്മിറ്റി പറഞ്ഞല്ല
Okay, then we can pause for it later. Anyway, the namespaces, C groups and Chirut, like CS root. Okay, namespaces, like what containers do with namespaces, it simply enables us to isolate the processes or the resource isolation. Like it helps us to simply resolve like isolate the resource run by each of the spawn containers and all. Like I am bit like oversimplifying things, but we have to go through it in a hurry. And there is C groups, and it enables us to like share the resources and distribute resources and those kind of things. When it comes to chroot or ch root, like it is for file system isolation, like isolating the whole file system, like responsible for each of these containers, maybe the application of Shadi and Mary and those kind of things. Okay, like those are the basic features allowed by Linux that is made use for these containers when Docker were introduced. And containers were doing good for me, and it solved a lot of problems, like especially for the DevOps case. Any DevOps case over here? Okay. Oh shit. Like I am going to offend you after something. Fine.
അല്ല DevOps specific അല്ല എല്ലാം ഉണ്ട്.
Great. Okay, fine. Same here as well. Okay, anyway, like it solved a lot of problems. Like even in the case of DevOps and all, like it made the deployment of an application, a complicated application, completely simple. Like I can simply like deploy and compile image kind of thing, and it's spin up and it works. But everything was good for me. Like until this specific incident happened to my life. Like it wasn't my life, like it was to my colleague's life. Like I forced him to use install Fedora on his Linux. Like I am working on a like a startup, so we got the freedom to install whatever we want on our systems. Yeah, so I forced him to use Fedora, but he went to the situation to develop or maintain an application developed by another company or by another peer of mine, and he actually did it on Ubuntu. So the application is similar Python application, but it got some complications with some DNN and kind of some additional packages and system related registries and all. It got some image manipulation things and all to do. So the problem was the whole system was developed on Ubuntu, and he wanted to set up the development environment on Fedora, and there was this package conflict. So I made his life worse, and after some like a long lengthy discussion, we decided to go with container based development, and that is where things starts to irks me. Like, trust me, it's like Dockers are not simply meant for developers. It's meant for DevOps case. Fine. And let's do the math. Like, why do they want to use containers for development? And what are the pros and what are the cons? Pros. Like, if I'm going to use containers for developer, it solves the distribution related problem. Like, the container will pack a whole Linux distribution into a container image. So like if I want to go with the container based development, then it solve the distribution related error. Like if a package is not maintained under APT and it is only available on DNF, and then if I'm going with the container based like development practices, like I can develop an application on my system, and it can be like roughly develop on any other system using the containers, provided that they share the like a compatible kernel version underlying. Anyway, and the second thing is it won't pollute the host system with the application specific resources. Like, so it's more like virtual environments in Python. Like if you guys are familiar with Python, like you will be using venv. Like it simply create a folder, and we will be enabling the virtual environment, and after doing my project I will be installing some dependencies for the Python thing, and everything I install using pip, like for the Python project, will be inside that folder. So after everything is completed, I can simply delete the folder and it will do the job. Like my system is not getting polluted. So it does the same thing but in a broad level. Like in this case, even if I installed a whole like a system package, it will not pollute my system. Like it will be inside the container. After the development I can simply remove it and the system will be okay, fine. And mostly that's it. Like if you are going into the like development using container method, that is the main thing we are focusing upon. Like that's the main advantage we are getting. And now we can do the cons. Fine. The images and container war. Like yeah, if you want to develop or make a container or want to develop using containers, like the first thing you want to do is like you want to package your system into image, Docker image, or a other Podman or any container image, and the first thing will be you will be building will be called an image. It's more like a like everything sourced into a compiled format, or maybe of some set of tarbars and all. Anyway, there is this concept, and if you really want to do something with it, like if you want to execute something inside your application for development, then you want to use containers. Like I mean, then you want to convert it into containers. Like then the image will be mounted on a specific or a specifically allocated storage space, and then you want to work on there. Like that is a bit complication. It's necessary for our development purposes. And there is the persisting changes and managing. Like if I started using containers for development and I want to install an intermediate like dependency or while developing these things, the problem here is that like it is bit hard to persist these things for the next runtime. Like if I install, say if I spin up a container of Ubuntu and I starting using it for my development, and I installed an application, maybe installed a dependency, say it's simply a curl. Okay, I installed curl on it, and I will be maintaining a Docker file along with my system. Okay, so that is how I will be packaging the application. That will be the blueprint for packaging the application. So the problem is like the next time I am going to run the same application, the two options I am left with will be like I can either restart the old container I have already spinned up, or in some cases I can rewrite the Docker file and rebuild it, and in some other cases like I can like commit the newly created container into a new image and I can go with that new image. So there are a lot of options and it's a bit complicated. There is not a standard procedure to do that. And there is the third problem, is the main problem for me, the volume mounting thing. So we talked about building the container and maintaining the Docker file and all, but if I really want to start doing development using containers, then I have to like somehow map my source code on my local machine to inside the container. So that is where the volume mounting kicking. So if you are familiar with the Docker in the rootful manner, like the default way to use it, then you will encounter a lot of permission related issue on volume mounting your source code into it. Like the code edited inside the Docker will not be accessible on the outside, like vice versa. And you can do some user ID mapping and all, but it is mostly solved by the rootless containers anyway. But there is also a catch on it. Anyway, the volume mounting is also an issue with Docker-based development, and managing the storage hungry monsters like Docker, Podman, whatever be that. Like it is not meant for development. Like each time I like build an image, like it creates a new like storage or new volume mounts in the case of containers and all. So these are hard to manage. Like each time I done with my setup, like I have to do the Docker PS or Podman PS, and I have to delete everything, and I have to do the same with the Docker images and also. There are some problems, and yeah, and the important part is I don't like these much complications for my development environment. Yeah, it can be simple case, and that's what is me, like I said it earlier. And I start thinking for the solution. Like yeah, it's been a month. Like I got a lot of solutions to do these things and make it more simple and easy to go with. And I know this thing like we need something special and something like Python virtual environment or something like it. It is a like a de facto standard for a virtual environment management in the developer community and all. And I got this solution, but I was too lazy to do these things. And back then I was like wandering around the Cochin Junction, and I seen this like a random beautiful girl, and she passed me a smile, and I suddenly get motivated like I should do this. I should do a change to the world, and I'm going to change the change the fate of the developers forever. And I created DevC. Yeah. And DevC is the application. Yeah, there's a like that's a frog. It's called Tad. Tad the frog. That's the name of it. Anyway. Yeah, it's more like whale, right? You resemble to that. That's the irony. It is inspired from Docker and made by my like
Docker തിമിംഗലമാണല്ലോ അല്ലേ?
yeah, exactly. And it got that
I mean,
exact color
there's
pattern.
no confirmation that it's not a whale looking at its land.
Yeah, you can interpret it in a way. Like that's the big thing about the logo. Okay, anyway, I will come back and appreciate the logo with more in detail later on. Let's talk about the DevC. Like DevC, it makes these scenarios more simple. Like we are going to the aim was to like solve the previously said issues and making a like containers based development environment, but it feels less like a container and more like a process running on your system. And but the main thing I have to solve here is that like the dependency issues and the distro switching issues. So the trick like it is mainly CS root. Like when we were talking about the main features of Linux that is used by the containers, like we were seeing the CS root, and he also like coined the jail thing. Yeah, that is what we are going to look. And if you're familiar with yeah, great. Okay, if you're familiar with the Linux environment, everything in Linux can be represented as represented as a like files. Yeah, like if you plug in a USB, like it can be shown as a file. Like if you run a process, it can be shown as a file, and everything, maybe even the network sockets and everything can be represented as a file. In the case of Linux kernels, so I can bundle a whole Linux distro apart from the kernel and all, like a root file system, as a separate root file system. So if I'm going to use chroot, like I will be having a root file system of a separate kernel. Like say the main thing shown over here will be my host system. Like let's say it's Popo's for this time. Like I don't like it anyway. And I will be having a root file system of a different distro. Like it can be Ubuntu or Fedora or Arch Linux. Yeah, probably Arch Linux. And what I'm going to do with chroot is something like using the chroot, I can run a new process inside the new root FS. Like the thing about the new process is that like the new process will be fake to know, believe that it is the root FS is its new like root. Like it will not be able to see other part of the application or the whole system and all. So we can do the isolation here. So that's the thing we use in like Docker containers for the like I mean file system isolation. But yeah, and yeah, it was more like the Deadpool's fantasy of going into a planet of idiots and being their superhero. Like we are creating a simple thing and like making that as our new root, and we run our stupid things over there, so it will not affect my actual parent system. So the idea is we will use a standard container building library for creating the root FS of a container written in a Docker file or sorry Docker file or container file. It seems more comfortable right now. Okay, fine. Okay, we are back anyways. Yeah. Okay. We'll be having a Docker file or container file in my system for my normal application development. Okay. And we will be using a building library to build a root FS. That is what we want at the end, and we'll be using a library for that thing. And we can also make use of the standard APIs to communicate with the normal container registry, so that we can pull new images from the existing container registry. And we will be adding the next thing, like we have to handle all sort of these cache like produced during the development or the building of these containers and all. Like as I commented earlier, like when we going with development using containers, like the cache and the storage maintenance is one of the main thing we have to talk about. So the cache has to be maintained decently, otherwise I won't be able to like forgive myself. And at the end, the user will be presented with a simple thing, maybe a familiar thing, so that they can enable their virtual environment and migrate all of their code into it, and they can simply start using it from there. And all of them should definitely work in rootless mode. Like we are not going to use sudo, like so that we are reducing the probability to like mess up with our operating system. I mean our main host system. And yeah, me being step on that were the objectives. So Builder was the first application or the first library I have chosen. Like it is the backend of Podman. You guys may already know about it, and it is compliant to OCA standards and all. Okay, if you're not familiar with OCA, like it's the Open Container Initiative, like the some standard
Docker
organization for
Docker, Podman,
yeah, everything should implement it. So yeah, so that's the common like interface for that those things. And Builder is compliant to that OCA standards, and also Builder can simply build a Docker image or container image from the Docker file or container file we give it to it, and it can also got the API integration to pull images from it. And if we got such a image for our application work, and then we can simply convert it into a root FS, like by simply mounting it into a like temporary storage and then copy pasting this thing and preserving the permissions and all. Then we got with the root FS, so we got everything we need, like maybe the important part we need. And yeah, and all of these changes together with the building caches and all will be maintained inside a like isolated folder inside our application, something like venv in the case of Python. So yeah, why? Because like we are developers, like we want to dig deep into it, like we want the transparency, we want the root file system to be visible, like we are not the DevOps newbies anyway. And in the case of Steerroot, like that's the main thing. Like if I got the rootfs, I really want to execute the rootfs, or like I want to put my code inside the rootfs and I want to start using it. Then only I can develop on it. And for that, I'm actually went with Beirut, and it's more like a mimicking software. I can say like yeah, it work like this. Like it got the depends upon the Linux feature called ptrace. That's a debugging feature, so that every like child processes spawned with the ptrace can be encountered before the each system calls, and it can send back its own custom calls or API or results back to it. And so it is basically going to intercept every request or every system calls we are going to execute through the application. And payroot will mimic, basically it will mimic the chroot and some binding mount kind of functionalities. So why we are not going with chroot? It is simply because like using chroot involve a lot of complexities. Like most of the time, like if it really want to work well, then we have to use the sudo. And to be honest, I didn't figure the correct way to use it right now. And there is also the use case of unshare. Like we can use the namespaces to make privileges to chroot environment and isolate it and run it over there. That will work, but still I have to figure out how to mount the code to there and make the make the UID things well, so the permission issue will not like come in. Like anyway, I'm going with Payroot. Okay, Payroot is more simple. Like it will work on the user space, and I can simply bind some of my folders from one place to another place, or at least for the for the process I am going to spawn using Payroot will know or think that is the case. Okay, fine. So we are using Payroot for that thing, and yeah. And the implementation, like we got everything, like we got the root efforts and we got the payroot, and the idea is simply like this. Like we will be using, yeah, I will come back to it, like okay, we will be using something like the root efforts. Maybe we will be using the payroot to spin a new process, maybe a bar shell or something in the payroot and the root efforts environment. And we will be binding our application source code into a random folder inside it, and I can start using my application right away from the shell. And those kind of ideas what I'm going to implement. And I'm going with Go, like it again rhymes anyway. Yeah. And the reason to choose Go was, first of all, builder was written on Go, so at the first earlier time I think like I can make use of the builder's actual packages as a modules inside Go, but it is not that easy. Like it got some complications. Like builder in the builder library itself is recursively calling it the actual process in recursively. So I got some problem doing with that thing. So currently we are still using builder, but we are not using builder as a module of Go. Anyway, that was one of the main reasons to choose Go as the solution. And if we are like mean about like packaging and deploying our application, then a compiled language got its advantages. Like we don't want to ship our interpreter. Like if I'm like going do with Python, then whenever I want to use the application, I have to ship my whole Python interpreter together with the application. So those kind of button are not there. So I want a like compiled application. When I think about compiled application, I don't want to go with C++, and I didn't get the time to learn Rust. And yeah, and it is finally released, and it is under GitHub Brutus DFC. And yeah, it was good to see. And like there were cross-compiled packages or binaries, and I also created like a single liner to install the things, and it was inspired from a like Docker's documentation. Like Docker used a
Yes.
single SS file to automatically detect the native
I do it all
package
the time.
manager. Sorry.
I do it all the time.
Yeah, that's a good place to go. Like I didn't see any other alternative, to be honest, to simply create a go like ready to go SS file, and they will simply identify the like the package manager, the default package manager of the Linux system, and we can use it for installing our like dependencies on it. And after that, we will be doing some additional stuff. We will be exporting our binary to our path and add some additional like bash completion profits and all, and everything will be set. And at the end, we get the application, and let's roll. Like, yeah, it's supposed to be there. It's our application
Post-
there.
Okay, come for FOSS Meet anyways.
Yeah, yeah. And
Free promotion ആയല്ലോ.
fine. This application, it's a completely CLI based application, and if I want to we are going to the use case actually. Case. Let's do a workable demonstration.
Okay.
Again, sorry for that. For example, I got a Docker file over here. Like it can be my application Docker file or something. Now it is similar, like it is pulling an Alpine image and installing curl into it and copying the test file seen over here to inside the Docker container. That's a usual Docker file. And if I want to build a environment like a devc environment out of it, I will be doing something like devc build, and then yeah, Kut is not there, and then there will be an env. I mean that will be the variable, like that will be the name of the folder. So yeah, that's it.
Okay.
And it will basically use the default Kutu. Yeah. If you want to specify detail, like you can also read out the help page, and there will be the detail use case of the -c contest fields and all. Fine. Build maybe env. Okay, I'm creating the env.
കുത്ത്.
What is that?
UUID gen is not
Yeah,
there.
fine. But it went with the thing. Okay, fine.
Now what do you want to say, bro?
Karma.
Okay, it's saying something else like maybe I can go with the Axel direct pulling. Maybe. Oh yeah, sure. Like okay, maybe I have to edit the
It is depending on an external dependency.
It must be lowercase.
no, yeah. But kidding. Alpine is the spelling is correct.
Wait.
Try
it's not-
Debian.
Yeah, you have to give it a.
Then
Docker.io maybe.
no,
No,
not
it's
recommended.
No, but that is not the problem here.
No,
It
no,
is
no, no.
looking for UUID gen, right?
Yeah, that's it resolved over here. Like that was something. It's like I didn't simply get the UID generation tool inside Go.
So you can see inside the tag, right? The tag name.
Yeah,
it has.
Wait, what is the error?
No,
Look, it
error
has
UI
uppercase.
error
No.
UID ada.
The error is different, right? It's not about the image, I think.
Yeah.
yeah.
Try, anyway, try. That's how it works anyway.
Oh.
Software development in a nutshell.
Okay,
I can
then
do
we can
something.
go with new method. Like it should actually work. I don't know why.
Yeah,
Always happens in
I
production,
also
eh?
was thinking about the same.
Let's go. We believe in you.
I think it's something to do with the disk. I don't know. And
What
but if I,
I guess.
Ah,
Yeah.
yeah,
I also
maybe.
had problems because of the disk.
It's a
Like
proprietary
to
desk.
yeah, I understand your thing. And maybe we can pull a new image directly from the disk.
Maybe-
Maybe I got
Debian to
Alpine.
Debian.
I'm not using
No, maybe in the base image.
Debian slash mini.
Docker.io/Alpine. It should work.
You just open the N folder.
Yeah, sure. Mount.
No
മൊത്തത്തിൽ
such.
scene ആണല്ലോ.
Something is terribly wrong, guys. So,
Try from the normal terminal.
ഇത് ഓൾറെഡി ഡെവസിക്കകത്താണോ എൻവയൺമെന്റ് അല്ലല്ലോ പുറത്തല്ലേ?
no, yeah,
Just try
I
and
am
pull it.
No such
Yeah,
file is
it's
there.
actually probably I'm going. I got some.
Sudo.
ആ ക്യാഷ് ഫോൾഡർ മൊത്തത്തിൽ
Wicked അതായിരിക്കും.
Yeah.
1 GB യുടെ Python.
Yeah,
Slash.
1D the Python. Like it's the Debian based thing. That's why. Sorry. POC,
Have you
pull,
tried this?
maybe Ubuntu. Yeah, it's working. Like it probably can be something like network issues. Maybe
Yeah.
it's working, and it created. Yeah, we got the photo over here. And how to activate it? Like it is much simpler than your source env bin activate.
Same
Just
setup.
like
Anybody got it?
Python.
Yeah,
Yeah.
that's Python thing.
Python we use.
And I am inside the thing. Like these things has to be figured out. Like in the case of APT based distros, like, there are some UID mapping things. I still want to figure it out. And anyway, I am inside the thing. And if I do the LS,
install NeoFetch.
yeah, sure. Okay. Okay, let's update the thing. It will update it and start everything inside. Like I'm completely inside the Docker environment.
ഇത് ആ പെർസിസ്റ്റൻസ് ആ ഫോൾഡർ തന്നെയാണോ അത് ഇമേജ് ആക്കുന്നുണ്ടോ പിന്നെ
Completely inside the ENV. Everything will be inside the ENV. There is a root folder.
അപ്പൊ ഇത് ഷിഫ്റ്റ് ചെയ്യണമെങ്കിൽ എനിക്ക് ആ ഫോൾഡർ ജിസിപ്പ് ചെയ്ത് കൊടുത്താൽ മതി
Yeah.
ഓ നൈസ്
But
Yeah.
that
Yeah,
will
but
be like
it's
there be some /tmp and those
There are
kind of
other
files.
files.
Yeah, it has to be removed.
ഓക്കെ അതുകൊണ്ട് ഒരു കമാൻഡായി നന്നായിരിക്കും ലൈക്ക്
Yeah,
എക്സ്ട്രാക്ട് ചെയ്യാൻ
Yeah, it can be added later.
ഓക്കെ
And apt insta, what do you say?
NeoFetch.
NeoFetch
Neo.
Fetch, right?
പിന്നെ ആർച്ച് യൂസറിന് NeoFetch അറിയത്തില്ല.
So
If you don't want to show up, you don't need
so
it.
ഓ എന്റെ
Yeah,
You don't
seriously.
install Arch unless you want to show.
Even in the case of ours, like I can serve
ഏയ്
it.
ഒരു NeoFetch ഇൻസ്റ്റാൾ ഡിപെൻഡൻസി നോക്കിയേ
Yeah.
Python
Why?
why?
And it will install. Trust
ഇവിടെ
me.
Litmagic ഓ.
ഓഡിയോ ഒക്കെ വരുന്നത് അവാഹിയൊക്കെ വരുന്നത് അസാഹിയൊക്കെ വരുന്നത്
അതെല്ലാം ഉബുണ്ടു ബേസ് ഇമേജ് ആയിരിക്കും കൂടുതലായി.
കൊണ്ടുകൊണ്ട് ഗുണമാണ്
Yeah, probably. It works.
ഈ സിസ്റ്റം അപ്ഡേറ്റ് ചെയ്യുന്നത്
Graphics driver ഒക്കെ
Like it's all with Ubuntu and all. Like you can try out everything you want.
Yeah,
Like
yeah.
there is some issues. Like I will come in and bring it. Okay, did anything crash? No, fine.
It's just pulling.
Yes.
I did.
Yes.
ക്ലാസിക് ഉബുണ്ടു
Like yeah, fine. Yeah, great.
ഇത് ഉബുണ്ടു സിസ്റ്റത്തിന്റെ കുഴപ്പമാവോ ഒന്നും ചെയ്യാൻ
Desk,
Yeah,
desk.
I think so. That's fair. Maybe let's go with something simple.
Lip paper utils.
Okay, there are some issues I have to figure it out.
Ask
Like
fix broker.
it was most
Ask install fix broker or something.
അല്ലല്ല ഇത് വേറെന്താ സീന ഫ്രഷ് ഇമേജ് അല്ല പ്രശ്നം ചെയ്തിട്ട്
So you don't have right privileges to the state data. That's what's causing this.
ഒരു അപ്പൊ
You can
സുഡോ
look
എങ്ങനെ
at
വർക്ക് ചെയ്യുന്നത്
the
ഇമേജിനകത്ത്
inside the image, it will work most like the root privileges of the current user session will be forwarded there. So even if we mount most of the /etc kind of thing, like it will not be get rewritten from inside the thing. That's why I gone with payload. Like it's mostly
Just
simple.
transfer the effective user.
Yeah. So yeah, and maybe we can simply go with this thing as well.
DPKG
Like
record.
if I want to edit the test file over here, like it's on my local file. I'm using nano is there. Yeah, nano is there. Okay, nano is not there. Maybe we
VI.
ഇത് ബീബി റൂട്ടിന്റെ കുഴപ്പമാണോ റൂട്ട്
Command.
ഐ മീൻ ആ എൻബ് കിട്ടുന്നില്ല
സിസ്റ്റം കോഡ് ബ്ലോക്ക് ആവും.
Okay.
ബ്ലോക്ക് ആവുന്നു
അല്ല എന്നാലും
something to do with any other.
Ghost script എന്താ സാധനം? Can you try to manually install that Ghost script?
വാട്ട്
Ghost
കമാൻഡ്
script is for that. This one, PostScript files, right? PDF
Yeah,
and
Ghost script.
PS thing.
Yeah.
Well, what does that got to do here?
No, it has nothing to do with
Yeah,
it.
it has nothing
I think NeoFetch was a very bad idea.
Oh yeah, the EFH was a bad idea.
Okay. Anyway,
Anyway, it
the
works.
idea was something
It
like
kind of like works.
I can
You
simply
did
go
this
with
in a week,
CAD.
huh?
What?
How long do you take to build this?
Maybe 3 days for the structures.
Oh
like
fuck,
then.
this is nice. Yeah, I know. This is good stuff. Huh?
And then I can like copy it so some like some test file do or something. Do
Just Docker provide
I'm
APIs
using
for-
something. Okay.
It's not a Docker thing, it's a Linux kernel
Yeah,
thing.
So yeah, the file is created over here and it's on the same thing, and I can open it and I can open it, no permission issues and all. So that's what it basically means, and it is most of the time working. Like I think it should
Good
be
stuff, yeah.
something wrong with the desk.
Three days.
How does socket connections work inside the thing? So can
Yeah,
I connect to host, let's say post-based system running on the
Like every network and all kind of things will be similarly mimicked by the p root. Like P-root is actually mimicking the environment.
So unlike Docker, there won't be separate network environment.
No. Everything will be the host. Like we just want to, we just want to mount the resolve conf inside it. Otherwise, the default root FS will not go the resolve configuration.
Understood. Yeah.
So fine. That will do. And
Can you tell me VNC server inside?
sorry,
BNC. Not now.
We'll
try that later.
Do you really want to
Not
test me?
now. We're running overtime.
Okay,
Yeah.
yeah, that's why.
Okay.
And there are some GPG key errors due to some like Unix like UID mapping thing we have to find out, and P-root is actually slow, like it is using ptrace and
They're all
mimicking
open
thing.
issues. People can contribute.
Yeah, surely that's why this emoji came. I'm actually looking for contributors. Like, is anybody interested? You are welcome.
I'll rewrite it in Rust.
Yeah, I will surely consider moving into Rust. For sure. Yeah, the credits for like it is written on GPL v3, and the cute little frog over there, like it's made by my roommate, my friend Devji. Like it is called Tag the Frog. Yeah, Devji. But it got no that Devji popular explainer. Like it's actually Dev space G. Okay, fine. And for confusion and things and clarification, like DevG got nothing to do with the name DevC. DevC means developer and container and those kind of things. And there is build.it is built on top of Apache 2.0 license, and there is P-root, and it is on top of V2, and it is it got this clause of saying like the license will be like it will be compatible with the later version. So it's okay V2. I mean P-root's V2. And yeah, I'm inspired from the last thing. Yeah, Amma ask me anything. I will reply if I know. Yeah, sure.
Did you see that girl again?
We'll ask those questions later. Okay,
No,
we're done?
To be honest, no. Yeah. Any technical questions?
സോ ഇത് ശരിക്കും ലിനക്സ് കർണലിന്റെ ഫീച്ചേഴ്സ് അല്ലേ ശരിക്കും ഇത് ഉപയോഗിക്കുന്നത്.
Yeah,
അപ്പോൾ ഈ
exactly.
ഡോക്കർ വരുന്ന സമയത്തിന് മുമ്പേ ലിനക്സ് കർണൽ ഫീച്ചേഴ്സ് ഓൾറെഡി ഉണ്ടായിരുന്നു.
Yeah, sure. Linux and all of these features were there. Linux Linux.
അല്ല
Yeah.
CS root അത് മനസ്സിലായി ഞാൻ പറഞ്ഞതിൽ
CS router, rooters. I mean, sorry, CS router, namespaces, C groups, everything were there.
പക്ഷെ
Yeah.
ഡോക്കർ ആണ്
Popularize
ആദ്യം
it.
അതിങ്ങനെ ഇംപ്ലിമെന്റ് ചെയ്ത് അങ്ങനെ
Yeah.
അല്ലേ.
So Docker was actually trying to like break away. Like they wanted to take all of these features, make it popular in DevOps, like create the field of DevOps itself. They wanted to like simplify the whole developer workflow in that space in 2010s.
Right.
Network isolation in handle.
Actually, there is no network isolation. Like currently, we are using P-root. I'm planning to switching into runc. Like that is the container thing. In that thing, like we will be handling those kind of things. But to be honest, I didn't figure out the correct configuration and all for runc. It's a bit complex. Like I didn't get the time.
Currently, 2 containers can run with the same.
Yeah, the big thing about is like that all the process isolation or the process will be run as my operating system process. So I got the normal like local hit system feed. So yeah.
You can run multiple environments at the same time, right?
Sure. Like,
So like, does it use any ports?
no, actually I will show that like if it works.
Oh, അങ്ങനെ.
Like for example, if I am doing this thing and I am doing a sleep for 10 maybe 100 seconds, yeah, it is working for now. And if I do the ps minus u, and I can actually see the like sleep over here. Like it is more like a system process. Nothing like it is so simple like a normal local host thing and all like local machine thing. But the dependencies and distro kind of things will be separately like handled, and we can go with our development. Yeah.
ഇതിനകത്ത് കെർണൽ ഇരിക്കുന്നില്ലേ സബ് ഫോൾഡറിനകത്ത്.
No. Kernel will be shared with the host. Yeah.
അപ്പൊ അവിടെ ഡിപെൻഡൻസി ഇഷ്യൂ ഇല്ല.
Our dependency issue like kernelന്റെ features എന്തെങ്കിലും അവിടെ യൂസ് ചെയ്യുന്നെങ്കിൽ compatible kernels
Kernel level stuff we can't do anything.
like അത് ഡോക്കറിലും അങ്ങനെ തന്നെയാണ്. Like containers kernel share ചെയ്യും.
ഇപ്പൊ ലിനക്സ് ഡെസ്ക്ടോപ്പ് ആപ്ലിക്കേഷൻ ഷിപ്പ് ചെയ്യുന്നതിന് കുറെ പ്രശ്നമുണ്ട്. സ്നാപ്പിനും ഫ്ലാറ്റ് പാക്കിനും. അപ്പൊ ഇതുകൊണ്ട് അങ്ങനെ ചെയ്തുകൂടെ? ഇപ്പൊ എനിക്കൊരു ഡെസ്ക്ടോപ്പ് ആപ്ലിക്കേഷൻ ഷിപ്പ് ചെയ്യണമെങ്കിൽ എനിക്ക് ഈ ഒരു ഇമേജ് കൊടുത്തു കഴിഞ്ഞാൽ ആൾക്കാർക്ക് എളുപ്പത്തിൽ അത് റൺ ചെയ്യാൻ പറ്റില്ല.
First thing, like if you want to install this thing, like you have to figure out your own scripts. I am not responsible for that. It is completely for developers. Like the problem is like if I want to do those kind of things, like then I have to do the like installation part, and I have to make the permission kind of things.
I think app image ഇങ്ങനെ ഫോളോ ചെയ്യാൻ തോന്നുന്നു.
Yeah, actually like Flatpak, Snap, all of them follow a similar kind of approach. Yeah. More like a containerized application. Yeah. Anything else?
Deva, you close?
Yeah.
Group photo.
Thank you. And there was a thank you and my credits. Sorry. And Devsi can be find over there, and you can follow my master. Sorry.
You are Devji?
No, I am Devsi. I am saying about Devsi. Yeah. I will be available at Mastodon or postdon.org. And yeah. Yeah, that's it. Thank you, guys.
ഒരു ബ്രൗസർ തരും.
FOSS Meet.
Yeah, let's go, Subesh.
നീയാണത് പറയേണ്ടത്.
.net. ഞാൻ പറയണോ?
ആ ഡോട്ടിങ് കൊണ്ട് കളഞ്ഞില്ലേ?
എന്ത് ചെയ്യാനാ, നമ്മളല്ല സീനിയേഴ്സാ.
ഓക്കെ, അടുത്ത മാസം ഫോസ് മീറ്റ്, ഞങ്ങൾ കൊച്ചിയിൽ ഫോസ് മീറ്റപ്പ് ഇല്ല. ഞങ്ങൾ നടത്താതിരുന്ന കാരണം NIT കാലിക്കറ്റിൽ എല്ലാ വർഷം 2005 മുതൽ ഒരു ഫോസ് കോൺഫറൻസ് നടക്കുന്നുണ്ട്. ഫോസ് മീറ്റ് എന്നാണ് പേര്. NIT കാലിക്കറ്റിൽ നീ ഓർഗനൈസർ ആണ്, ഇതിന്റെ ഓർഗനൈസർ ആണ്, അത് ബാക്കി പറയുന്നില്ല. സോ വൈശാഖ് ഈസ് വൺ ഓഫ് ദി ഓർഗനൈസേഴ്സ് ഓഫ് ഫോസ് മീറ്റ്. സോ ഇത് 2005 മുതൽ നടക്കുന്ന ഒരു ഇവന്റ് ആണ്. ഇന്ത്യയിലെ ലോങ്സ്റ്റ് റണ്ണിങ് ഫോസ് കോൺഫറൻസ് ആണ്. 3 ദിവസം ഉണ്ട്. സോ ഇതിന്റെ രജിസ്ട്രേഷൻ സ്റ്റാർട്ട് ചെയ്തിട്ടുണ്ട്. ഷെഡ്യൂൾ എല്ലാം ഐ തിങ്ക്
Schedule is there and on that section. So yeah, people who are here itself are coming. Alan Paul Varghese is standing right next to me, sitting right next to me. So yeah, we'll have a lot of interesting speakers and workshops, and more than the speakers or the workshops, it's mostly about the hacker culture. We'll have a lot of fun. Last time Subin and Devdutt, all of them were there. Make sure to register for the event and hope to see you all for FOSS Meet.
Okay.
We endorse FOSS Meet.
We endorse FOSS Meet.
We are coming to FOSS Meet. FOSS Meet at Kochi will be FOSS Meet.
Folks, we have a group photo now. Please join us for that.
Yeah, and we'll close.